Hello and welcome to fastfunctionalskills.co.uk, the UK's #1 functional skills service for students, employers and training providers. So in this video we'll be going through everything you need to know for functional skills maths. Now this video will show you worked examples and techniques for all the key topic areas such as fractions, decimals and percentages, area and perimeter, geometry, probability, averages, data, and many more. So let's get started.
Let's get things started with numbers and place value. So what we have here is a very complicated looking number, and what I want to teach you is just what each column represents. Now starting at the left hand side of the decimal point, the 4, this is in the units column. The 3 is in the tens, the 5 is in the 100s, 2 is in the 1000s, 5 is in the 10,000s. So you can see that as we are going to the left, each new column is 10 times greater than the one before it. So if the 5 is in the 10,000s, then this 8 is going to be in the 100,000s, and this 3 is going to be in the 1 millions. Now on the right hand side of the decimal point, we are now dealing with fractions. Now the first column, and a lot of people struggle to remember this, is that this is tenths. So this column here is the tenths column. The 9, this is in the 100ths column, and this 1 is in the 1000ths column. So the next column would be 1 over 10,000, after that 1 over 100,000, etc. Okay, so if you're asked a question, what is the value of the 3 in this number, then this 3 would be 3 million. This column here, the 8 would be 8 times 100,000, 800,000. 5 times 10,000, 50,000. 2 times 1,000, so 2,000. What's the value of this 5? Well, it's 5 times 100, so 500. 3 times 10, so 30. Just 4 on its own. The value of this 7 is 7 tenths, 9 100ths, and 1 thousandth. So let's have a look at a few examples. What is the value of the 6 in the following numbers? Okay, so in this first number here, this is the units, this is the tens, this is the hundreds. So this is simply 6 multiplied by 100, so 600. In here we've got units, tens, 100s, and this is thousands, so that is 6 multiplied by 1000, which is 6,000. Hopefully you don't need to even do this calculation, it should be fairly obvious. This third example, this is in the tenths column, so that is simply 6 tenths. Here, well, there's 2 6's here. This 6 here is in the tens column, so that is the 6 of 60. And the other 6 here, that is in the 100ths, so that is 6 100ths. In this final number, units, tens, hundreds, thousands, so this is in the 10,000s, so again 6 times by 10,000, which is 60,000. Moving on now to reading numbers. So I've deliberately written down here 2 horrendous looking numbers, but they're actually quite easy to read provided you group them into groups of 3 from the right. So put a comma after every 3, like so. You need to remember that the first comma is for thousand, the second comma is for million, and the third comma is for billion. Now as long as you can read a 3-digit number, you should be fine. So this is 58,264,596,737. With this next number, it's a decimal, but the decimal point bit doesn't make it any harder. Just remember that after the decimal point, when you say point, you just read the numbers individually. So this is 0.32. You will hear some people say 0.32, but it should be 0.32. Okay, so from the decimal point going to the left, comma after every 3, 1 2 3, 1 2 3, 1 2 3, 1 2 3, and again first comma is 1,000, second is million, third is billion, and this is now trillion. So if I were to read this number, I could write it as well, but that'll take a long time, so I'll just read it. This is 1,267,439,000,000. Okay, we can't say 0,123, that's just 23,674.32. Okay, so for this question we need to write these worded numbers as actual numbers in figures. So just remember let's just write down just a daft number. So we need to remember that the first comma is for 1,000 and the second comma is for million. Maybe put in that one as well for a billion. Okay, so 3 million. Well, remember, million is just a comma, so 3 comma. 1,000, remember, is the next comma, so all I need to do now is write 245 comma, and now just write 272. 3,245,272. That's exactly what's written. Let's try the next one. So 3 million. Now I need to write 3 digits before the next comma for 1,000. So I'm not just going to plonk in a 6. I can't write 600 either, or because that would be, or 600,000 of course, so that has to be 006 and 272. Okay, the next one, 3,000,005. So 3 comma for the million. The next comma is for 1,000, but there aren't any thousands, so I have to fill these with 3 zeros. And 5, again, I have to write 3 digits, so that has to be 005, not 500 or 050, because that would be 500 or 50 respectively. So let's just test this. 3 million, 0,000. Okay, let's not even bother saying that, shall we? 3 million and 5. Perfect. Let's take a look now at negative numbers and positive numbers. Now, whenever you're looking at questions involving positive and negative numbers, it might be worth doing a number line. So 0, 1, 2, 3, 4, etc. to the right, and we can see that these numbers are increasing in size. So as we go to the right, the numbers are getting bigger. So therefore, as we are going to the left, the numbers are getting smaller. And for some people, I can see why this is quite confusing, because what's bigger, -4 or -3? Well, the bigger the number, that means it's more to the right. So -3 is to the right of -4, so -3 is bigger than 4. And that seems confusing because we know that positive 3 is smaller than 4. So it's almost like everything's the wrong way round when you're dealing with negative numbers. But to solve any issues, draw out a number line. Circle the bigger of the two numbers. So what's bigger, 5 and 11? Well, we could do a number line, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we know that the numbers are getting bigger as we go to the right. So here's 5, here's 11. So 11 is bigger than 5, but you probably knew that anyway. For number 2, again, you probably know that a positive number is always bigger than a negative number. But if you need to, do your number line, 0, -1, -2, -3 to the left. 1, 2, 3, 4, 5 to the right. Well, 5 is further to the right than -3, so 5 is bigger. Now, -7 and -8, this is one where you might want to do a number line. So 0, -1, -2, -3, -4, -5, -6, -7, -8. Okay, so we know that as we go to the right, we're getting bigger. So we've got these two numbers. Which one is more to the right? Well, it's the -7. Okay, so let's have a look at this one now. You could do out your entire number line, but you might just want to do a little bit of the number line to get a little bit of a flavour. -1, -2, -3, -4, ... So I'm going to get to -15 before I get to -32 if I keep going. Which one is further to the right? Because remember, the ones to the right are bigger. So -15 is bigger than -32. Another way you could do it is, well, what is bigger, 15 or 32? Well, 32 is bigger than 15, so therefore it's the other way round in negative numbers. Okay, so -15 is bigger than -32. You don't have to write it out with inequality symbols if you don't want to. Just remember it's the opposite way round to what it would be with positive numbers. Insert one of these symbols between, so this means less than, and this one here means greater than. So a lot of people call these the crocodiles, and the crocodile's open mouth is always open towards the bigger thing. Okay, so 13 is bigger than 5, so 5 is less than 13. The crocodile's open mouth is facing towards the bigger thing there. Okay, right, for the next one we might want to do a number line. So 0, -1, -2, -3, -4. Keep going, we're going to get to -11. Well, we can see that -3 is greater than -11. So minus 3 is greater than minus 11, or alternatively look at 11 and 3. 11 is bigger than 3, so therefore minus 3 is greater than minus 11. Remember that when you deal with it as if they were positive numbers, it's the opposite way round. Okay, minus 12 and minus 18. Let's use this other method again, turn them into positive numbers. So 12 and 18. What is bigger, 12 or 18? Well, 18 is bigger than 12. So therefore, if we're looking at minus numbers, minus 12 and minus 18, it's the other way around. Minus 12 is bigger. So minus 12 is greater than negative 18. But feel free to do a number line. On to ordering numbers. So let's put these numbers in order. So first of all, I would say, well, hopefully you know that positive numbers are bigger than negative numbers. So let's take the positive numbers and put them in order. So 0 is smaller than 1, 1 is smaller than 7. Okay, so what is bigger, negative 5 or negative 8? Well, let's look at 5 and 8. 8 is bigger out of 8 and 5, but if it's minus 5 and minus 8, then minus 5 is greater. So minus 5 will be there, and minus 8 is the smallest. So negative 8, negative 5, 0, 1, 7. Okay, with this set of numbers, we've got two positive numbers, so 3 and 19. 3 is smaller than 19. Now, with the remaining four negative numbers, let's just order them as if they were positive numbers. So let's go 11, 12, 26, 53. So the order for negative numbers would be the opposite way around. Minus 53, minus 26, minus 12, minus 11, and then the 3 and the 19. So sometimes it's easier ordering them in the required order as they were positive numbers, and then reversing that order for the negative numbers.
Are you looking for further help to pass your functional skills maths course? If so, then head over to our website passfunctionalskills.co.uk, where you'll find full coverage of all the necessary topics with revision videos divided up into 3 key sections using numbers, common measures, shape and space, and handling information and data. You'll also find practice tests, exam style questions, and a full set of mock exams as well. So check out passfunctionalskills.co.uk.
Okay, so addition and subtraction. So I'm just going to show you the fairly straightforward written methods for adding and subtracting. The most important thing is make sure that you line things up on the right hand side. So for the 37, don't write 37 under the 3 and the 2. That would be completely wrong. 3, 2, 3, line them up on the right hand side, so the 7 is under the 3. Okay, let's add them column by column. 3 plus 7 is 10. Now we're only going to write down a single digit number, so we'll write down the 0 of the 10 and carry across the 1. 3 plus 2 is 5, plus that 1 is 6. 3 plus nothing is 3. So that is 360. Let's look at the next example. So 46 to 2, and again make sure everything is lined up on the right hand side. Starting on the right hand side, 2 plus 5 is 7, 2 plus 7 is 9, 6 plus 3 is 9, 0, 4. So that comes to 40,997. Now for subtraction, it's exactly the same thing. Make sure everything's lined up on the right hand side, and start on the right hand side, same as you would for adding. 6 minus 2 is 4, 5 minus 3 is 2, 9 take away nothing is 9, so that is 924. Example 4, 1, 8, 2, 6, 2, 7, 4, 5, 1. Again, everything is lined up on the right hand side. 2 take away 1 is 1, 6 take away 5 is 1. Now, we're going to run into a bit of bother here, because 2 take away 4, well, some people would just write 2, but that would be 4 take away 2, not 2 take away 4. You can't write minus 2. So what we need to do is borrow from the column to the left. So the 8 will become a 7, and this 2 becomes 12. So 12 take away 4 is 8, 7 take away 7 is 0, 1 take away nothing is 1. So 1, 0, 8, 1, 1. If you're not used to doing this borrowing, then definitely that's something that you're going to need to practice to get it up to speed. And this final example, I'm sure this one here has some extreme borrowing going on. So in the very first column, we're going to be doing 7 take away 8, but we can't take 8 from 7, so we need to borrow from the next column over, but the next column over is empty. Okay, so I need to fill this column up first, and to do that I need to borrow from the column to the left of that one. So this 1 becomes a 0, so that this 0 is now a 10. Now, in order for me to do the 7 take away 8, I can now borrow from here. This 10 will now become a 9, and the 7 becomes 17. 17 take away 8 is 9. 9 minus 6 is 3. 0 take away 9, that can't be done, so 9 becomes an 8. The 0 becomes a 10. 10 minus 9 is 1. 8 minus 8 is nothing, so I could put in a 0, but I'm not going to bother. So the answer is simply 139. Okay, so multiplication by units of 10. Multiplying any whole number, and in these examples we have whole numbers, not decimals. If you're multiplying by 10, just add a 0. If you're multiplying by 100, add 2 zeros. If you're multiplying by 1,000, add 3 zeros. You add the same number of zeros as there are on the number, in other words. So 36 times 10, add a 0. So 36 with a 0, 360. 45 times 100 is 45, add 2 zeros, so 4,500. 85 times 1,000 is 85, add 3 zeros, so 85,000. Things are a little bit more complicated though when you're multiplying by 10, 100 or 1,000 when we have decimals involved. Now when you're multiplying by 10, you're going to move the decimal point 1 position. For 100 you move the decimal point 2 positions, and for 1,000 3 positions. Again, the number of places you move the decimal point depends on the number of zeros in the number. Now, because we're multiplying, we're going to be making the number bigger, so that means we're going to move the decimal point 1 or 2 or 3 positions to the right. So the first example, we're multiplying by 10, so we're going to move the decimal point 1 position to the right, so it will now be between the 8 and the 6, so that'll be 198.625. The next one, multiplying by 100, 2 zeros, so we're going to move it 2 positions, so it will now sit between the 6 and the 2, so 1,986.25, and by 1,000, that's 3 positions we're moving the decimal point, so 1, 2, 3, that will be between the 2 and the 5, so 1,962.5. Now the final 3 examples are a little bit harder because, well, the first one, we know that if we're multiplying by 10, we're going to move the decimal point 1 position, but then it doesn't really, well, maybe this one doesn't confuse you too much, but some people prefer the decimal point to sit between 2 numbers, and here 5 is the n number. So first of all, let's turn this into 4.5 and put some zeros on the end. Now you can move the decimal point so it sits between 2 numbers, so that is 45.000, and that is of course just 45 because the 0.00 isn't adding any value whatsoever. I'm going to do the same thing with 3.2 times by 100, put some zeros on the end so that I can clearly move the decimal point 2 positions, so that's going to be 320.000, in other words 320. 1.07 times 1,000, it looks like I can only move the decimal point once or twice, but if I just chuck some zeros in, it doesn't, like, you can't put in too many. It's going to move 3 positions, so 1, 2, 3. So that will become 1070.0000, in other words, 1,070. On to multiplication. So first of all, 36 multiplied by 5. Nobody expects you to know your 5 times table beyond 10 times 5 or maybe 12 times 5 at a push. So here we're going to need a written method. So 36 goes on the top, 5 goes on the bottom. The shorter number should be on the bottom. So here we've got a 1-digit number versus a 2-digit number, so put the 1-digit number underneath. So we're just going to do 5 times 6, then 5 times 3, and write those numbers in here. So 5 times 6 is 30, so that is 0. Move the 3 across because, carry 3 because we can't, we would never write a 2-digit number here. Now we're just doing 5 times 3, which is 15, plus the 3 is 18, so that is 180. Let's do another example. So 56 multiplied by 8. So again, 8 times 6 followed by 8 times 5. 8 times 6 is 48, carry 4. 8 times 5 is 40, plus 4 is 44. So that comes to 448. 38 times 23. They're both 2-digit numbers, so it doesn't really matter which way round you put them. So this is slightly different. We're going to start off with the 3. Start with this number here. We're going to do 3 times 8, then 3 times 3. Then we're going to move over to the 2 and repeat the process. 2 times 8, then 2 times 3. I've seen many students at schools just do 3 times 8 and then 2 times 3. Absolute carnage. So let's start with the 3. 3 times 8 is 24. 4, carry 2. 3 times 3 is 9 plus 2 is 11. Moving on to the 2, but before we do that we're going to put in a 0. I'll explain why in a moment. 2 times 8 is 16, 6 carry 1, 2 3s are 6 plus 1 is 7. And now we just need to add these two rows together. So 4 plus 0 is 4, 1 plus 6 is 7. Just ignore all these small numbers that you used when you were carrying numbers over, and 1 plus 7 is 8. So the answer is 874. Now on this top row we've done 3 lots of 38, and on this bottom row we've done 20 lots of 38. So in total that would be 23 lots of 38. And that's why I put in the 0, otherwise that would simply have just been 2 lots of 38. It's a very common mistake as well, is omitting that 0. On to squaring. Now if you ever see this small 2, that means you're squaring, and 5 squared means 5 multiplied by 5. So 5 squared is 25. 8 squared is 8 times by 8, which is 64. And 10 squared is 10 times by 10, which is 100. And incidentally, these are examples of some square numbers. Whenever you multiply a number by itself, you get a square number.
Right, let's take a look at division. So unless you can do these in your head, you are going to need to use a written method, which is the bus stop method. And what you are dividing goes inside the bus stop. So here we are dividing 44 by 2. So 44 goes inside the bus stop and 2 goes on the outside. And now all we're doing is single digit division. 4 divided by 2 is 2. 4 divided by 2 is 2. So the answer is 22. No problem there. The next question is very similar. We are dividing 369 by 3. So 369, the number we are dividing, goes inside the bus stop, and what we're dividing by goes on the outside. 3 divided by 3 is 1. 6 divided by 3 is 2. 9 divided by 3 is 3. So the answer is 123. The next question, there's something slightly different happens here. We're dividing 865, so that is going to go inside the bus stop, by 5, which goes on the outside. 8 divided by 5 goes once with a remainder of 3. So we can divide 8 by 5 once, so we're going to put 1 on top of the bus stop, and that remainder of 3 we're going to park on the next digit to create a 36. So now we're doing 36 divided by 5. Now 36 divided by 5 is 7. 7 5s are 35, so that is a remainder of 1. So the 7 goes on the top, and that remainder we park on the next digit. So the 5 becomes a 15. 15 divided by 5 is 3. So the answer is 173. Now this final example, something ever so slightly different happens with this one as well. And the reason why is because we have a number at the start that is less than 2. So we're dividing 152 by 2. So 1 divided by 2. Now a lot of people make the mistake of writing 2 up here, but that is 2 divided by 1. We want to do 1 divided by 2. Well, how many 2's go into 1? Well, the answer is none. So we need to put in a 0, and we're going to carry, well, there's a remainder of 1, so the 1 will move across. To keep it short, if the number here is less than the number that you're dividing by, just put in a 0 and carry the number over. 15 divided by 2 is 7. 7 2's are 14, so that's a remainder of 1. That remainder of 1 gets parked on the 2 to turn it into a 12, and 12 divided by 2 is 6. So the answer is 76. Hopefully you can appreciate that the 0 at the beginning isn't doing anything useful there. Let's take a look at BIDMAS. Now this word BIDMAS tells us the order we need to do things in. So B stands for brackets, I stands for indices. Now indices are these little numbers here, like 8 squared, meaning 8 times 8, or 5 cubed, 5 to the power of 3, or 6 to the power of 4. So these small numbers, these are indices, sometimes referred to as powers. D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction. So if we have, in a question, if we have some brackets and some division, we need to do the brackets before we do the division. So let's look at a couple of examples. So here we have subtraction and we have multiplication. So let me just write the word BIDMAS again. So here we have subtraction and multiplication. Well, multiplication comes first. So we need to do the 6 times by 2 and then take that away from 20. 6 times 2 is 12. So this question is 20 take away 12, which is 8. It would be wrong to do 20 take away 6 first. 20 take 6 is 14. 14 times by 2 is 28. 28 is wrong. We have to do the multiplication before we do the subtraction. In this question here, let me just write the word BIDMAS. We have brackets and we have multiplication. So we need to do the brackets first. 3 plus 7 is 10. So 10 times by 9, which is 90. Okay, in this question here, again, let's just look at it using the word BIDMAS. We have some indices, we have subtraction, and we have multiplication. Well, let's do the indices first. 4 squared. So 4 squared means 4 times by 4, which is 16. So the question is now 16 take away 5 multiplied by 2. Multiplication comes next. So 5 times 2 is 10. So the question is now 16 take away 10. So the answer is 6. Okay, in this final question here, we have 2 brackets. So we need to sort out this bracket here and this bracket here before we subtract one answer from the other. Now let's look at the left-hand bracket first. We have indices. Again, let's write BIDMAS again. We're going to have to do 2 separate BIDMASes here. So in the left-hand bracket, we've got indices, multiplication, and adding. So let's do the indices first. So 3 times 3 is 9. So this is 3 plus 2 times 9. Multiplication occurs before addition. So 2 9s are 18. So this is 3 plus 18. And 3 plus 18 is 21. So on the left hand side we have 21. Take away. Okay, now let's look at this bracket on the right hand side completely separately. Again, we've got indices, subtraction, and division. Do the indices first. 10 squared is 10 times 10, which is 100. Take away 8 divided by 2. We're going to do the division next. 8 divided by 2 is 4, so it's 100. Take away 4, which is 96. So the final calculation is 21 take away 96, which is a little bit nasty. I probably could have planned a slightly better set of answers. So for this final irritating bit of subtraction, I'm going to turn it around. What is 96 take away 21? That's 5, that is 7. So if 96 take away 21 is 75, then 21 take away 96 is minus 75. So all of this comes to negative 75. So just remember, BIDMAS tells us the order we need to do things in. B brackets, I indices, division, multiplication, addition, subtraction, and as long as you follow the rules, do these in the right order, then you should always get a correct answer.
Okay, so let's move on to the topic of fractions, which is a really important topic. So first of all, writing fractions. So a relatively straightforward question. A company has 20 employees, 3 of them are part-time. What fraction are part-time? Well, how many are part-time? Well, the answer is 3. Out of how many? Or out of 20. So as a fraction, that's just 3 out of 20. Sometimes the question might ask you what fraction are full-time or not part-time, and that would be the opposite fraction. I'm not sure if opposite fraction is the technical term, but that's often how I refer to it as. So if 3/20ths are part-time, then the rest is 17/20ths, which is the full amount, which is 20/20ths take away 3/20ths. 39 out of a company's 50 employees are never late. What fraction is this? Well, how many are never late? That's 39. Out of how many? Well, out of 50, so 39 out of 50. Sometimes it's worth just checking, can you simplify the fractions? But in both of these examples, these fractions can't be simplified at all. So talking of simplifying fractions, let's simplify some fractions. So 2/4. We just need to look at the numbers and think, right, what can we divide them both by? Well, these are both even numbers, so we can divide them both by 2. If you divide the top number by 2, we get 1. If you divide the bottom number by 2, you get 2. The next fraction, 5/15, well, look at the numbers. What can you obviously divide them both by? Well, you can divide them both by 5. They're both in the 5 times table. So if I divide the top number by 5, I get 1. If I divide the bottom number by 5, I get 3. 70 over 90. Now, I know when I'm working in schools, a lot of students will think, oh, you can divide them both by 2. Okay, yeah, you can divide them both by 2, but there is another very, very obvious times table that these both belong to, and that is the tens. And if you can divide the top and the bottom by 10, it's as simple as just chopping off that 0, so 7 over 9. It is frustrating that students can't go directly from 70 over 90 to 7 over 9. It doesn't even involve any brain power whatsoever, and they would try and think of it as, okay, well, 70 divided by 2 is 35. They might get that wrong. 90 divided by 2 is 45, and maybe not obviously notice that this fraction here can be simplified. I think a lot of students always assume that it's always division by 2, but it's not. The first one you were dividing top and bottom by 2, the next one you were dividing top and bottom by 5, and this third one dividing top and bottom by 10. Okay, so this fourth example here, we can't divide the top and the bottom by 2 because this is an odd number. So if we can't divide by 2 and it's not obvious to you, well, try dividing by 3. Both of these are in the 3 times table. 12 divided by 3 is 4, and 15 divided by 3 is 5. This next example, well, we can divide by 2, so that would become 6 over 9, but it's always worth checking the fraction again. 6 and 9 are both in the 3s, so by dividing again but by 3, I'm going to get 2 over 3. I could have just divided to begin with by 6, but I think it's much easier simplifying it twice by small amounts rather than looking for the biggest possible number. 75 over 100, so what times table are both these numbers in? They're both in the 5s. 75 divided by 5 is 15, and 100 divided by 5 is 20. Both these numbers are still multiples of 5, so divide by 5 again, we get 3. Divide by 5 again, we get 4, 3/4. 200 over 400 is fairly similar to the 70 over 90. Chop off a 0, top and bottom, you've divided by 10, 20 over 40. Chop off a 0, top and bottom, you've divided by 10 again, 2 over 4, and 2 over 4, that is 1 over 2. 88 over 99, well, we can't divide by 2, because this 99 is odd. We can't divide by 3, because 3 doesn't go into 88. Well, what would you do next? Most students would say try dividing by 4, but if you can divide it by 4, then you could have divided it by 2. So if you can't divide by 2, don't bother even considering 4, 6, 8, 10, 12, any even number. It's just the odd numbers. Divide by 5, you probably would have spotted that they were in the 5s, but you can't divide by 5. Can you divide by 7? No, you can't. You can skip 9, because if you can divide by 9, then you could have divided by 3. So let's try 11, and yes, they're both in the 11 times table. 88 divided by 11 is 8, and 9 divided by 11 is 9. Let's take a look at equivalent fractions. So 1/3 is the same as how many ninths? Think of it this way: if you're, let's say, a goalkeeper and you save 1 penalty in every 3, how many penalties would you expect to save if you faced 9? So how many times more penalties are you taking? Don't see it as you're facing 6 more penalties plus 6. See it in terms of multiplication, 3 times more. So if the bottom is being multiplied by 3, for an equivalent fraction we need to multiply the top by 3 as well. 1 times 3 is 3. 5 over 6 is the same as what over 24? The bottom number we have multiplied by 4, so for an equivalent fraction we need to multiply the top by 4 as well, so 5 4s are 20. 3/7 is how many 49s? Well, 7 multiplied by 7 is 49, so for the equivalent fraction we need to multiply the top by 7, 7 3s are 21. 5 over 11 is the same as what over 88? Well, the number on the bottom we've multiplied by 8, so for an equivalent fraction we need to multiply the top by 8 as well, so that is 40 over 88. Converting mixed numbers to improper fractions is a useful skill. If you don't know how to do this, what you do is we do 2 multiplied by 6 plus 5. So, and that is going to be over 6. How many sixths are there in 2 and 5 6? Well, there's 2 times 6, which is 12, plus 5, 17. 1 and 7 ninths, how many ninths is that? Well, that's 1 times by 9, which is 9, plus 7, which is 16, so 16 over 9. How many tenths is 4 and 7 tenths? Well, it's 4 times by 10, which is 40, plus 7, which is 47 over 10. And how many elevenths is 5 and 5 elevenths? Well, that is 5 times by 11, which is 55, plus 5, which is 60. So 60 over 11. Going the other way round, I'd say that this is probably slightly harder. 5 quarters, we're going to turn that into a mixed number, so a whole number and a certain number of quarters. Now we need to remember that the line of a fraction means divide. So what is 5 divided by 4? How many 4s go into 5? Well, 4 goes into 5 once with a remainder of 1, so that is 1 and 1 quarter. So it's always, this number here is always the same as that number there. So 23 over 5. How many 5s go into 23? Well, 5 goes into 23 4 times with a remainder of 3, so that's 4 and 3 over 5. 17 over 6. 17 divided by 6. How many 6s go into 17? 6 goes into 17 2 times with a remainder of 5, so that's 2 and 5/6. 13 over 2. 13 divided by 2. How many 2s go into 13? 2 goes into 13 6 times with a remainder of 1, so that is 6 and 1 over 2. So again, you can see that these denominators are the same throughout. Okay, adding and subtracting fractions. I'm going to show you a technique called the crisscross smiley face technique, which I normally teach to, or most students just seem to have more success with this method. It's not perfect because you don't always get a fraction in its most simple form, so it's worth, well, you'll see from one of the examples what I mean. So what we're going to do is we're going to do 1 times by 5, which is 5, plus 2 times by 1, which is 2, over 2 times by 5, which is 10, and 5 plus 2 is 7, so 7 over 10. So you can see the criss-cross and the smiley face here. So let's try another one. 3 over 7, take away 2 over 5. 3 times by 5 is 15. Take away 2 times by 7, which is 14, over 7 times by 5, which is 35. So that is 1 over 35. So the only difference between adding and subtracting is you write in a minus sign instead of a plus sign. 1/5 plus 3/8. 1 times by 8 is 8, plus 5 3s are 15, over 5 times 8, which is 40, and that comes to 23 over 40. None of these fractions could be simplified. Let's look at the final example. 2/3 plus 1 over 6. 2 times 6 is 12, plus 1 times 3 is 3, over 3 times 6, which is 18, so 15 over 18. And here we have the slight problem. You need to check, can you simplify your answer? In this case, yes, you can. We can divide the top and the bottom by 3. 15 divided by 3 is 5, and 18 divided by 3 is 6. So that's for me, that's the only disadvantage of the crisscross smiley face. You don't always get a fraction in its simplest form. Okay, fractions of amounts. So half of 24. So maybe you just know that the answer is 12, but the reason we get there is it's 24 divided by 2, which is 12. Now, most people can half numbers, but some people get stuck when you have to do 1/3 or 1/4 or 1/7. So we can see for the first example, it's the total divided by the number on the bottom. So we're going to do the same here. 1/3 of 30 is 30 divided by 3, which is 10. 1/4 of 44 is 44 divided by 4, which is 11. And 1/7 of 28 is 28 divided by 7, which is 4. These ones are all quite easy because the numbers on the top were 1. But what about when the number on the top is not 1? So what is 3/5 of 35? Well, what we need to do is take our total, divide it by the number on the bottom, and then multiply by the number on the top. 35 divided by 5 is 7. 7 times 3 is 21. Next example, 2/3 of 30. Take your total, divide it by the number on the bottom, and multiply by the number on the top. 30 divided by 3 is 10. 10 times by 2 is 20. Basically what we're doing here, if I just use this example, is we're working out what 1/3 of 30 is. Well, that's 30 divided by 3, which is 10. So if 1/3 is 10, from 1/3 we're working out 2/3, which would be double the 10, which is 20. So this is the calculation to work out 1/3, and then we're doubling it because we're working out 2/3. Sometimes it's good to understand why you're doing certain things, might help you remember it, I suppose. So the next one, 3/4 of 44, take your total 34, divide by the number on the bottom to work out 1/4 and times it by 3 to get 3/4. 44 divided by 4 is 11 and 3 times 11 is 33. 5/7 of 28, take your total, divide by the number on the bottom, multiply by the number on the top. 28 divided by 7 is 4, 4 times 5 is 20.
Moving on to the division of decimals. So if we're just dividing a decimal by a whole number, this is nice and easy. So just do your normal bus stop. So 15.2 is going to go inside the bus stop and 2 is going to go on the outside. If you can divide 152 by 2, then you can easily divide 15.2 by 2. All you need to do is just remember to put a dot above, put a decimal point above the decimal point of the 15.2 on top of the bus stop there. So 1 divided by 2 can't be done, so 0, move the 1 across. 15 divided by 2 is 7 with a remainder of 1, and 12 divided by 2 is 6. So the answer here is 7.6. On to the next one, 0.000462 divided by 5. Again, we are dividing a decimal by a whole number, so not really a big problem. So 0.000462 goes inside the bus stop, 5 goes on the outside. Make sure you put a dot on top. 0 divided by 5 is 0, 0 divided by 5 is 0, another 0, another 0, 4 divided by 5 is 0, move the 4 across. 46 divided by 5 is 9 with a remainder of 1, 12 divided by 5 is 2 with a remainder of 2. Now we need to put in another 0 so that I can place that remainder of 2 on top of it, and 20 divided by 5 is 4. So here the answer is 0.00000924. Now the next 3 questions, these are the sort of questions that people often struggle with. Now we need to remember this. 8 divided by 4 is 2. Normally when I ask students what is 80 divided by 40, they will tell me that the answer is 20, but that is not correct. How many 40s go into 80? Well, the answer is still 2. So if I multiply the numbers by both numbers by 10, I still get the same answer. In fact, let's do that again. 800 divided by 400, the answer is still 2. So what I'm going to do here is exactly the same thing. I'm going to multiply both numbers by 10. So 163 will become 1630, and 0.2 multiplied by 10 becomes 2. That's the whole point of multiplying both numbers by 10, because it turns this nasty decimal into a whole number. And now we can divide 1630 by 2 using a bus stop. 1 divided by 2 is 0, move the 1 across. 16 divided by 2 is 8. 3 divided by 2 is 1 with a remainder of 1. 10 divided by 2 is 5. So the answer is 815. Now a lot of people want to fiddle this answer, but remember, 8 divided by 4 is 2, 80 divided by 40 is 2, 800 divided by 400 is 2. All these questions, all these different calculations here result in the same answer of 2. 163 divided by 0.2 is exactly the same answer as 1630 divided by 2, in the same reason that these calculations here result in 2. Okay, let's do the next one. So we're going to multiply both numbers by 10, so that becomes 850 divided by 0.1 times 10 becomes 1, and 850 divided by 1, well that's really easy, that's just 850. And this last one, 837 divided by 0.5 becomes 8370 divided by 5. This one will need a bus stop. How many 5s go into 8? Well, it goes once with a remainder of 3. 33 divided by 5 is 6 with a remainder of 3. 37 divided by 5 is 7 with a remainder of 2. 20 divided by 5 is 4. So the answer here is 1674. So dividing a decimal by a whole number, easy peasy, but dividing by a decimal is a bit of a problem. So just remember, multiply both numbers by 10 and you get rid of that nasty decimal.
So ordering decimals, I would probably suggest put them in a column: 1.101, 1.112, 1.011, 1.012 and 1.201. So let's assume we're doing the smallest first. So in the units column, 1, 1, 1, 1, 1, we can't tell them apart. Let's look at the tenths column. We've got 1s, 0s and a 2. Actually, let's put, well, we can see that 2 is the biggest of the numbers, so this is the biggest of the 5 numbers. So 1.201, that's the biggest number. So we were after the smallest ones. So we can see we've got 2 that have got a 0 and 2 that have a 1. Well, 0 is less than 1, so these 2 here are smaller than the top 2. Now, if we look at these numbers, units are the same, tenths are the same, hundredths are the same, but in the thousandths column, we've got a 1 versus a 2. So this number here is the smallest. So 1.011 followed by 1.012. So now it's just a question of putting the top 2 in order. In the units, everything's in order. In the tenths, it's not in order. In the units, everything is the same. In the tenths, everything is the same, but in the 100ths, again, we've got a 0 and a 1. 0 is less than 1, so 1.101 is the next smallest, followed by 1.112, and then 1.201, so we now have them all in order. Let's move on now to rounding. So here we're rounding to the nearest whole number. When you're rounding to the nearest whole number, you need to look at the value of the digit that occupies the first decimal place. If there's anything beyond that, just ignore it. So what we're looking at here, if we're rounding to the nearest whole number, we're looking at the 2, because that's occupying the first decimal place. Is it 5 or more, or is it less than 5? If it's 5 or more, then we'll round up 1. If it's less than 5, we will round down. So because this is a 2, this will round down to 13. Basically, 13.2 is closer to 13 than it is to 14. 45.7 to the nearest whole number, we're looking at the first decimal place. It's greater than 5, so that will move the 5 up to a 6, so that will be 46. 95.5, here we have a 5, so 5, remember, rounds up, not down, so the column to the left will move up 1, so that will be 96. 37.1978, again, to the nearest whole number means we're looking at the first decimal place. Anything after that is completely irrelevant, so ignore it. Here, 1 is less than 5, so this will simply round down to 37. So remember, when you're rounding to the nearest whole number, you're looking at the first decimal place. If you're rounding to the nearest 10, you're looking at the units column. Again, if it's 5 or greater, we round up, so 6 is greater than 5, so this 5 will become a 6, so that will be 60. In other words, 56 is closer to 60 than it is to 50. 82, we've got a 2 here, so that will round down to 80. 85, we've got a 5, so remember 5 rounds up, not down, so that will round up to 90. And for this one, if we're rounding to the nearest 10, again, we're just interested in the units column. Everything after that can be completely ignored. 4 is less than 5, so that will round down to 1380, and we don't put 0.00, so 1380. If we're rounding to the nearest 100, then we're thinking of the digit that is occupying the tens column, and again, 5 or more rounds up, less than 5 rounds down. So 459, we've got a 5, so remember that will round up, so the column to the left will move up 1, so that will become 500. So in other words, 459 is between 400 and 500, but it's closer to 500. 628, we've got a 2 in the tens column, so that will round down to 600. Again, 628 is between 600 and 700, but closer to 600. 1893, so for rounding to the hundreds, we are looking at the next column along in the tens. We've got a 9, so that will move the 8 up 1, so this 8 will become a 9, and everything after that will become a 0, so 1900. Let's find the hundreds column here. So if we're rounding to the hundreds, we're looking at this digit here, which is an 8. So this will, because 8 is greater than 5, the column to the left will move up by 1, and then everything beyond that will become a 0. But if we move the 9 up 1, that will become 10. So this 9 will become a 0, and the 6 will become a 7. So that will become 1354700. So remember, all the columns afterwards, you just fill in with zeros. So there we go. I'm not sure how you read that number. Oh yeah, 13,547,000. To the nearest 1,000, we're looking at the digit that occupies the hundreds column. And again, 5 or more rounds up. So here we've got an 8, so this will round the 7 up 1 to 8, and everything after that will become a 0, so 8,000. 7894 is between 7,000 and 8,000, but it's closer to 8,000. 3,500, we've got a 5, so that will round up. 5 goes up, not down, so the 3 will become a 4, and everything after that becomes a 0. Here we've got a 6 in the hundreds, so the 2 will become a 3, so 1, 3, everything else will become a 0, so 13,000. If we're rounding to one decimal place, we're interested in the value of the second decimal place, and again 5 or more rounds up. So here we've got a 6, so the 5 will move up 1 to a 6, so 13.6. 98.93, rounding to one decimal place means we need to look at the second decimal place. It's less than 5, so that will round down to 98.9. 102.5867, we're only interested in the second decimal place, everything else completely ignore. It's an 8, so we're going to round that 5 up to 102.6. Again, one decimal place, we're looking at the second decimal place, everything beyond that we can ignore. This 8 is greater than 5, so the 9 will move up 1, but 9 plus 1 is 10, I can't write 10 here, so this becomes a 0, and this 5 will become a 6, so that will become 676.0. Two decimal places, we're interested in the third decimal place. Here we've got a 5, so the 8 is going to move up 1, so 56.79. Again, we want the third decimal place, we're not interested in the fourth, that's completely irrelevant. Here we've got a 6, so that will move the 9 up by 1, which will create a 10, which means the 8 next to that will become a 9, so that becomes 36.90. And you do have to put the 0 in, because if you ignore the 0, then you've only got one decimal place, and we want two decimal places. Let's take a look at this final example. We've got a 6 occupying the third decimal place. Everything beyond that we can ignore. 6 is greater than 5, so the 8 will move up 1 to 9, so 420.99. Three decimal places means we're interested in the value of the fourth decimal place, and again it's the same rules. If we're rounding to 67 decimal places, then you look at the 68th. So here we've got a 7, that's going to round the 9 up 1 to a 10, so that will become a 0 and that will become a 7, so that's 45.870. Well, you do need the 0, otherwise you don't have three decimal places. Ignore the 3 and the 2, it's the 6 that counts, and that's going to round this 5 up by 1, so 52.986. And again we can ignore the 201, we're only interested in the 5, and that will round the 8 up 1 to a 9 to create 89.999. Okay, on to estimating. Now the key thing with estimating is that we round the numbers to one significant figure. So 41, we'll call that 40. 87, we'll call that 90. What is 40 times by 90? Sorry, I shouldn't say it's equals, I say it's approximately. 4 times 9 is 36, and just put those two zeros back in there. So that is an estimate for 41 times 87. Okay, we're going to round to one significant figure here, so what that means is we're rounding this number to the nearest 100, so that is just going to be 100, and this is going to be 300. 1 times 3 is 3, put 4 zeros back in, 1, 2, 3, 4, so the answer is 30,000.
Are you looking for further help to pass your Functional Skills Maths course? If so, then head over to our website passfunctionalskills.co.uk, where you'll find full coverage of all the necessary topics with revision videos divided up into 3 key sections using numbers, common measures, shape and space, and handling information and data. You'll also find practice tests, exam style questions, and a full set of mock exams as well. So check out passfunctionalskills.co.uk.
Moving on to percentages. So converting fractions to percentages. Now the most crucial thing is remembering that the word percent means out of 100. So a percentage is a fraction that is out of 100. So think back to when I was chatting about equivalent fractions. 50 times what is 100 times 2? So for an equivalent fraction we need to multiply the top by 2 as well. So that is 14 out of 100, so 14%. So if the denominator is 50, you're just doubling the top number to get the percentage. 25 multiplied by 4 is 100, so do the same to the top for an equivalent fraction and you get 84, so that is 84%. 20 times by 5 is 100, so 12 times by 5 is 60, so that's 60%. 3 over 10 is the same as 30 over 100, so that is 30%. 4/5 is a bit of a tricky one, but what you could do is turn them into 50ths, 40 over 50, which is the same as 80 over 100, so 80%, or alternatively 4 over 5 is the same as 8 over 10, 80 over 100, so 80%. Okay, so these denominators are 50, double the top number, 25, quadruple the top number, 20, multiply the top number by 5, 10, just chuck a 0 on. That's quite easy really. 3/4 is one you just need to know. It's 75%. 1/4 is 25%. Just learn these. 1/2 is 50%, 1/4 is 25%, so 3/4 is 75%. 13 over 50, that's the same as 26 over 100, so 26%. 25 times by 4, so 2 times by 4 is 8, so that is 8%. 20, we're multiplying by 5, so 9 times 5 is 45, so 45%. 8 over 10 is 80 over 100, so that is 80%. 3 over 5, again that's 30 over 50, so 60 over 100, so 60%. A quarter is 25%. 18 over 50, double the top, double the bottom, so that is 36%. 3 over 20, the bottom is being multiplied by 5, so do the same to the top, so that's 15%. And 7 over 10, just stick a 0 on, so 70%. So some of them are much easier than others. The denominators of 20, 25 and 5 can be a bit of a fiddle, but as long as you've got a denominator that is a factor of 100, then it's all relatively straightforward. Okay, now calculating a percentage of an amount. We need to remember that 10% is 1/10, and the reason why is 10% means 10 over 100, and we can simplify that to 1/10. So the question is also, well, what is 1/10 of 240? 240 divided by 10, 24. So remember that 10% is often just as easy as taking off a 0. So 36, 99. Okay, here we can't take off a 0, but if I divide that by 10, it's 43.5. Now, if we can work out 10%, we can work out 20%. So what is 10% of 240? 10% of 240 is 24. So if 10% is 24, then 20% is, well, that is twice 10%. So double 24, we get 48. The next question, 10% is 12. So 20% is double that, 24. For the next question, 10% is 15. So 30%, well, that is 3 times more than 10%. So it's going to be 15 times by 3. So that is 45. 60% of 110, again, work out 10% first of all. 10% is 11, so 60% is 6 lots of 11, so 66. So if we can work out 10%, you can work out 20, 30, 40, 50, 60, 70, 80 or 90%. Although having said that, 50%, I'd probably just half it rather than do 10% and multiply by 5. If we can do 10%, we can do 5%. So 10% is 24. So 5% is half of that, so 5% is 12. 10% is 12. So 15% is a combination of 10% plus 5%. Think of it as blocks of 10s and 5s. So if 10% is 12, 5% is 6, so 15% is going to be 12 plus 6, so 18. For 35%, well, 10% is 32, and 5% is 16. Now 35% is 3 10% and 1 5%. Well, we know 5% is 16, so we want 3 lots of 32, 30, 60, 90, 96. So therefore 35% is going to be 96 plus 16, which is 102, 112. 50% of 240, as I mentioned earlier, I wouldn't bother working out 10% and multiplying by 5, just half it. 50% is 1/2. What's 1/2 of 240? Well, that's 240 divided by 2, 120. 25%, remember that is a quarter. So this question is, well, what is 1/4 of 120? 120 divided by 4, well, 12 divided by 4 is 3, so 120 divided by 4 is 30. For 75%, again, I would work out what 1/4 is. So 320 divided by 4 is 32, divided by 4 is 8. So 320 divided by 4 is 80. So 1/4 is 80. So 3/4 is 80 times by 3. So therefore 3/4 or 75% is 80, 160, 240.
So far, when we've been calculating a percentage of an amount, we've been working with nice percentage amounts like 10%, 20%, 25%, 5%, 50%, etc. So what do we do when we've got really horrible amounts like 36, 52, 47? So to do this, you need to develop an understanding of percentage multipliers. What do we multiply 512 by if we're trying to calculate 36% of it? Well, the answer is you need to multiply 512 by 0.36. 0.36, this is the percentage multiplier for 36%. Now, let's think about this for a minute. Well, first of all, so the calculation is going to be 0.36 times 512. Now, before we calculate this, where does the 0.36 come from? Well, if you want, you could just see it as it's 36 divided by 100. In other words, this is the decimal equivalent of 36%. What does percent mean? Percent means out of 100. So 36% means 36 out of 100. The line of in a fraction means divide, and 36 divided by 100 is 0.36. As I say, it's the decimal equivalent of 36%. So this is all we need to do. 0.36 multiplied by 512, and that comes to a total of 184.32. 52%, the percentage multiplier is, well, if 36% goes to 0.36, then 52% goes to 0.52, and so the calculation is 0.52 times 2865. We've done the hard work, now we just need to type it into a calculator. So 0.52 times by 2865, and that comes to 1489.8. And finally, 47% of 98,123, well, the percentage multiplier for 47% is this number here divided by 100. You're probably not even going to think of it as 47 divided by 100. It's simply 0. And then your 47 multiplied by 98,123, and 0.47 multiplied by 98,123 comes to 46117.81.
So far we've looked at 10%, 20%, 5%, and any multiple of 5 and 10% basically. So how do you work out 36% of 512? Well, this is a very quick thing for me to teach, which means it sort of quickly registers with your brain, but it's very easy to forget from experience. But this is really, really important. Assuming you're able to use a calculator here. Now, it really drives me crazy when I give a question like this to a student and they'll work out that 10% is 51.2, so 30% is 51.2 times by 3, 5% is 51.2 divided by 2. I mean, these are crazy calculations when you've got a calculator that you can do the whole thing. We need to understand percentage multipliers. So what we're going to do is we are going to multiply the percentage multiplier by the total. That's why it's called a multiplier, because you multiply it. And the multiplier for 36% is 0.36. It is the decimal equivalent of 36%. It is 36 divided by 100. So 0.36 times by 512. I should actually work out what the answer is, but to be honest, I'm sure you can type things into your calculator. 0.36 times 512. It's not going to be pretty. We get 184.32. What is the multiplier for 52%? Well, 0.52 times 2865. I'm not even going to bother working out the answer, because the crucial thing is, do you know what to type into a calculator? 47%, the multiplier is 0.47, so we're going to multiply that by 98123 to get an answer. Okay, so now on to percentage increases. So here we are, we probably don't need a calculator for these. All we need to do is work out 10% and then add it on. So 10% of 160 is 16, so we're now increasing 160 by 16. 160 plus 16 is 176. For the next question, 10% is 25, so 20% is going to be 50, so I'm adding 50 on to 250. 250 plus 50 is 300. 50% is half. Half of 180 is 90, so it's 180 plus 90, so 270. Now, if we're increasing by 11%, this is quite a horrible number. So think back to multipliers. 11% of an amount. If I said, what is 11% of 325? The calculation would be 0.11 times 325. So you could do that calculation and then add it on to 325. But even better, instead of using this basic percentage multiplier, use a different multiplier, the multiplier for a percentage increase. So the basic multiplier is 0.11, but for an increase, add 1.11. So 1.11 times by 325, and that will automatically take you to the final answer. 1.11 times 325 is 360.75. The basic multiplier for 28% is 0.28, but for an increase it would be 1.28. So it's 467 multiplied by 1.28, or 1.28 times 467, it makes no difference. And that comes to a total of 597.76. 93%, the basic multiplier is 0.93. So for an increase, it's going to be 1.93. So 1.93 multiplied by 361. 1.93 times 361 comes to 696.73. Now we're looking at percentage decreases. So this is exactly the same slide as 2 slides ago, except it says decrease instead of increase. What I'm going to do is I'm going to work out 10% of 160, and this time I'm going to subtract it. 10% is 16, so 160 take away 16 is 150, 144. Second one, 10% is 25, so 20% is 50, so I'm decreasing 250 by 50, giving me 200. 50% of 180 is 90, so I'm subtracting 90 from 180, which is in fact 90. Now on to multipliers. Now this is probably a more challenging thing to try and communicate. You could work out 11%, 0.11 times 325, and then subtract that total from 325, but there is a smarter way you can do it. Imagine you're buying, I don't know, let's say a pair of shoes, a pair of trainers, and it's 10% off. If it's 10% off, what does that mean? 10% off means you pay 90%. So if the trainers were £85, 10% reduction means 90% of 85. And the multiplier for 90% would be 0.90, or just 0.9 times 85. So the multiplier for a 10% decrease is 0.9. Remember that if you're taking off 10%, you pay 90%. If it was 20% off, you'd pay 80%, so it would be 0.8. So 20%, the multiplier would be 0.8. Okay, so if we are decreasing 325 by 11%, that means there's going to be 89% left. So we need to work out 89% of 325. So 0.89 multiplied by 325. That is the hard bit. The easy bit is typing it into the calculator, which is what I'm doing right now. And that comes to 289.25. If you're decreasing 469 by 28%, 100% take away 28% is 72%. So we need to work out, well, what is 72% of 467? 0.72 times by 467.72 times 467, and that comes to 336.24. If you're decreasing something by 93%, let's say it's 93% off £361, then you're paying 7% of £361. So 0.07 times 361, and that comes to, 0.07 times 361, which is 25.27. Yeah, be really careful with a single digit percentage amount. Remember that is 0.07. So just a quick recap on multipliers. If for example, I asked you to work out 14% of an amount, you would use 0.14. If you wanted to increase by 14%, then you'd use 1.14, and if you wanted to decrease by 14%, 100 take away 14 is 86, so that would be 0.86. 63%, basic multiplier 0.63. If you're increasing by 63%, be 1.63, and for a decrease, that would be 37% of the total. So let me just write a 63% decrease, so that'd be 0.37. If you can get your head around these multipliers and apply that, then that puts you in a position as being a very strong mathematician, in my opinion. On to calculating percentage change. A boy earns £10 per hour, his salary is increased to £12 per hour. What is the percentage change? So all we need to remember is that to calculate a percentage change, it is the difference divided by the original multiplied by 100. However, we don't always have to, well, let's see what happens here. We don't even need to think of this calculation because this was quite obvious. So what is the difference? The difference is 2. It was originally 10. So if you had a calculator, you could type into your calculator 2 divided by 10 times 100. However, all we're literally doing is just turning 2/10 into a percentage, and 2 out of 10 is the same as 20 out of 100. So that is a 20% increase because £2 is 20% of £10. Let's have a look at another one. Again, this one doesn't require a calculator. The salary increase has gone from £25 to £29, so that is a difference of 4. It was originally 25, and again, this is easy to convert into a percentage because 25 is a factor of 100. 25 multiplied by 4 is 100, so multiply the top by 4 as well, we get 16, so that's 16 over 100, so that is a 16% increase. In this final example, again, because the starting amount is quite nice, this is really quite straightforward. It's a difference of £26. It was originally 50, so 26 out of 50 is the same as what out of 100? Well, the number on the bottom has been doubled, so we'll double the number on the top. So that's 52 hundredths, so that is a 52% increase. It's exactly the same when you're doing a decrease. Here the salary has gone down from 10 to 8, so it's a difference of 2. It was originally 10, so 2 out of 10 is the same as 20 out of 100, so that is a 20% decrease. This one's gone from 25 down to 17, so that is a drop of 8. It was originally 25. So turning that into an equivalent fraction out of 100 requires me to multiply the number on the top by 4 because 4 25s are 100. So that is 32 100ths, 32%. Here we've got in the third example a drop of £9. It was originally 50. 9 out of 50 is the same as 18 out of 100. So that is an 18% decrease. You could get questions where you are required to use a calculator. The percentage profit is just the percentage increase in the value of the thing. So again, let's just think of the formula. It's the difference divided by the original multiplied by 100. Now, we didn't really use the calculator on the previous 2 slides because the amounts were kind of easy to work with. So let's work out the difference. It's 28,900 take away 12,800. So that is a difference of 16100. It was originally 12800 before it increased. So I'm going to do the top divided by the bottom multiplied by 100. 16100 divided by 12800 times 100 is 100, and I'm just going to round it to the nearest whole number. That is a 126% increase. Now this is quite an interesting one because I know a lot of students will not think it's possible to have a percent that's greater than 100. If something doubles in value, that is a 100% increase. So if it's more than 100%, that means it is more than doubled in value. If I round this up to 13,000 and double it, I get 26,000. So yeah, we can see that this new amount is more than double what it was previously. So that is why the percentage increase is greater than 100%. The percentage loss is just the percentage decrease in the value of the item. So again, we'll use the formula. What is the difference between the two amounts? It's 85,400, take away 45,200. That is a difference of 40200. It was originally 85400. So again, top divide by bottom times by 100. So 40,200 divided by 85,400 multiplied by 100. And I'll just round that to the nearest whole number. That is a 47% percentage loss, or a 47% decrease in value. Okay, let's take a look at reverse percentages, which are quite challenging because the question is being asked the wrong way round. What you want is a question where Sarah earns a certain amount of money, she gets a 5% salary increase. What is her new salary? Here we know the new salary, and we need to work out what the old salary was. So I'll put OS for the old salary. It's been increased by 5%. So the old salary would have been multiplied by 1.05. 1.05 being the percentage multiplier for a 5% increase. And that would have given us this new value of 29,400. So the old salary was multiplied by this to get this. So therefore the old salary can be calculated as 29,400 divided by 1.05. So the old salary was £28,000 exactly, and that feels good because that's a nice number. This next example, the old value of the car was multiplied by 1.3. This is the multiplier for a 30% increase to give us £58,500. So the old value of the car is 58,500 divided by 1.3, and 58,500 divided by 1.3 is $45,000. Okay, a yacht has dropped in value by 15%, so its original value was decreased by 15%. Now remember, for a decrease, if you're buying a pair of trainers, it's 15% off, you pay 85%. So we're working at 85% of the old value, and it's giving us this new value of 3.57 million, but we can just put 3.57. I'm sure that'll be fine. So the old value of the yacht is therefore 3.57 million divided by 0.85. So therefore the old value of the yacht is, let me just grab the calculator, 3.57 divided by 0.85, and that comes to 4.2 million. So we call these numbers here the percentage multiplier, and the reason is because you multiply them. But in these questions with the reverse percentages, you end up dividing by these figures because we're working the question backwards. So moving on to fractions, decimals, and percentages. Here we're converting decimals to percentages. To go from a decimal to a percentage is very easy. You just multiply by 100. And multiplying by 100 means moving the decimal point 2 positions. And if you need to put in some zeros to help you do that, by all means go ahead and do so. So 1, 2, so that is 20.000. In other words, it's 20%. 0.56 multiplied by 100. If you've only got 2 digits, then this is the percentage amount here. In fact, we could have just put 1 0 on and just got 20%. So this is 56%, 0.32, 32%. So it's as straightforward as multiplying by 100, as you can see. To go from percentages to decimals, we're doing the opposite, is dividing by 100. So 42%, 0.42. 95%, 0.95. Hopefully, with these sorts of questions, you don't need to worry about how to move the decimal point. It's just, if this is the percentage amount, put a 0 and a dot in front of it. But be careful with a single digit percentage amount. It's not 0.7. 0.7 has the same value as 0.70, so that is 70%. So 7% is 0.07. Yeah, don't forget that 0. 1.2%. Okay, this it is easy to get wrong. Again, we're dividing by 100, so if you want, just put some zeros in, 1.2, and we're moving the decimal point 2 positions. So the answer here is 0.012. So converting percentages to fractions, we just need to remember that the word percent means out of 100. So a percentage is a fraction out of 100. So 33% is 33 over 100. This fraction cannot be simplified. 97%, 97 out of 100. This fraction also can't be simplified. 35%, well, that is 35 out of 100. But here we've got two numbers that can be divided by 5. 35 divided by 5 is 7. 100 divided by 5 is 20. So 35% is 7/20ths as a fraction. 14% is 14 over 100, 14 hundredths. We've got two even numbers, so divide top and bottom by 2, we get 7 over 50. There we go. So nice and easy converting percentages to fractions if you remember that a percentage is a fraction out of 100. So for fractions, decimals and percentages, it's really, really important that you memorize all of these values here. Hopefully you know that 1/2 is 50%, but I know lots of students who don't know that 1/4 is 25% and that therefore 3/4 is 75%. These are three really, really important ones. And it's worth learning what the decimal equivalents are as well. 1/2 0.5, 1/4 0.25 and 3/4 0.75. But if you know the percentages, then it's quite easy to go from the percentages down to the decimals, just divide by 100. Okay, 1/10 is 10%, 0.1. Really, really useful. 1/5, a lot of people won't know what 1/5 is, but remember that 1/5 is the same as 2/10, just double the bottom and the top, and you can see that 2/10 is the same as, well, 2 over 10 is the same as 20 over 100, so 20% and 0.2. Always worth remembering too that 1 out of 1 or is the same as 2 out of 2 or 3 out of 3. When the number on the top and the bottom are identical, then that is 100%, and, well, as a decimal is just the number 1. Anything divided by itself is 1. I don't think 1/20th is the most important one for you to learn, but if you can remember that a 1/20th is 5%, that might get you out of trouble in the odd question here or there. But definitely focus on learning 1/2, 1/4, 3/4, 1/10. They are the key ones, and then probably 1/5 is a useful one as well.
Okay, let's look at how to convert fractions to decimals. So first of all, when you have fractions where the denominator is 10 or 100 or 1,000 or any unit of 10, converting the fractions to decimals is really easy. Now, 3/10 is simply 0.3 because this column here is your tenths column. So all you need to do is put 3 in that column and you've got 3/10. So 3/10, 0.3, 7/10, 0.7. So when it's out of 10, you're just creating a decimal with one decimal place. If it's 1/100th, you're creating 2 decimal places. So 17 out of 100, well, that is just 0.17. So 2 decimal places. Similarly here, 9 out of 100. So a lot of people will think falsely that this is 0.9. Oh, that is not correct because 0.9 is 9/10. So that is not correct. We need 2 decimal places when we're dealing with 100ths. So that is 0.09. Okay, so just remember, if it's tenths, 1 decimal place. If it's 100ths, 2 decimal places. Nice and easy. Okay, so now we're converting fractions to decimals where the denominator is not 10 or 100. So if you don't have access to a calculator, this is what you need to do. So the line of a fraction means divide. So 3/8 means 3 divided by 8. So what we're going to do is a bus stop method. So what we are dividing is 3, that's going to go inside the bus stop, and what we are dividing by goes on the outside. Now this looks a little bit weird because normally when you're doing division, you're normally dividing a big number by a small number. Here we are dividing a small number by a number that is bigger than that number. So that's why it looks a little bit weird. Now let's get going. So what is 3 divided by 8? How many 8s go into 3? Well, the answer is 0 with a remainder of 3. Now, bit of a difficult start, I appreciate. So what we need to do now is put a decimal point in, or maybe at the very beginning, just turn 3 into 3.0. Now that remainder of 3 will get carried across to create a 30. 30 divided by 8 is 8, 16, 24. So that's 3 with a remainder of 6. So put in another 0 and then the 6 can sit on there to create 60. What is 60 divided by 8? Well, that is 7. 7 8s are 56. So that is a remainder of 4, which will sit on this 0 that I've just written in. 40 divided by 8 is 5. Okay, so 3/8 is 0.375 as a decimal. So remember, 3 out of 8 is less than 1. If you've eaten 3/8 of a pizza, you've eaten less than 1 pizza. So it makes sense, therefore, that our answer should be 0 point something. Let's have a look at another example. 4/5. Remember, that means 4 divided by 5, because this line of the fraction means divide. So we are dividing 4 by 5. We might want to turn it into 4.0, put a decimal point above. How many 5s go into 4? Well, none, with a remainder of 4. 5s into 40 goes 8 times. So 4/5 as a decimal is 0.8. Okay, with these ones here, I'm just going to show you how to do this using a calculator. Remember, the line of a fraction means divide, so on your calculator just type in 21 divided by 50, and if you type in 21 divided by 50, your calculator might say straight away 0.42, or it might say that it's 21/50ths, in which case press a button, which the SD button maybe, or maybe there's another way on your calculator to turn a fraction into a decimal. So 3/10. So on your calculator, 3 divided by 10, your calculator will tell you 0.3. If you've got a really, really basic calculator, then the decimal answer should come out straight away. 12 over 25, that is 12 divided by 25, and 12 divided by 25 on your calculator is 0.48, and 11/20, 11 divided by 20, and 11 divided by 20 is 0.55. So just remember, if you're using a calculator, just top divided by bottom. That's exactly the same if you're not using a calculator as well, of course, in which case you'd use the bus stop method. Now, some of these questions here are probably just worth memorizing. So for example, it's worth memorizing that a fifth is 0.2. You could use a calculator, you could use the bus stop method. What I like to do with fifths, with certain students, is turn fifths into tenths. The number on the bottom has doubled, so for an equivalent fraction, double the number on the top, 2/10, and as long as you know how to write tenths as a decimal, then this bit should be quite easy. Worth remembering that 1/2 is 0.5, 1/4 is 0.25, and if 1/4 is 0.25, then 3/4 is 0.75. So some of them, if you don't know them, are definitely worth committing to memory. Certainly 1/2, 1/4, and 3/4. But worth remembering that fifths can be easily converted into tenths, and once you've got a fraction with a denominator of 10, then they're really easy to turn into decimals. 2/10, 0.2, 3/10, 0.3, 4/10, 0.4, etc. Are you looking for further help to pass your Functional Skills Maths course? If so, then head over to our website, passfunctionalskills.co.uk, where you'll find full coverage of all the necessary topics with revision videos divided up into 3 key sections: using numbers, common measures, shape and space, and handling information and data. You'll also find practice tests, exam style questions, and a full set of mock exams as well. So check out passfunctionalskills.co.uk. Okay, so let's look at converting fractions into percentages. You need to remember that percent means out of 100. So a percentage is a fraction, it's just the equivalent fraction out of 100. So 21 out of 50 is the same as what out of 100? Well, the number on the bottom has been doubled. So for an equivalent fraction, multiply the number on the top by 2 as well. So that is 42 out of 100, so 42%. Tenths are easy, just stick a 0 top and bottom, so that is 30%. 12 over 25, or 25 will be multiplied 4 times to turn it into 100, so do the same to the top. 12 fours are 48, so that is 48%. 11 out of 20, the number on the bottom has been multiplied by 5 to take it to 100, so multiply the top by 5 for the equivalent fraction out of 100, so that is 55 out of 100, so 55%. Now fifths can be a bit problematic. You might want to think of it like this. Well, what do you multiply 5 by to turn it into 100? You multiply by 20, so do the same to the top, and 1 times 20 is 20, so 1/5 is 20%. It might just be worth remembering that a fifth is 20%, and that will help you remember that 2/5 is 40%, 3/5 is 60%, etc. Another way you could do it is, let's say 4 out of 5 is the same as 40 out of 50. And now we're going to do the same as we did at the beginning, so just doubling the numbers at the top and on the bottom to get 80%. Or alternatively, 4 over 5, you could turn that into 8 out of 10 and then put the 0 top and bottom, and that's another way you can get the 80%. But quite handy if you just remember that a fifth is 20%. 1 half, just remember that half is 50%. Very handy to also remember that a quarter is 25% without having to do any calculations to work it out, and therefore 3 quarters is 3 lots of 25, so 75%. So do please learn a half is 50%, a quarter is 25%, and 3 quarters is 75%. Now these fractions here are a bit nasty to turn into percentages, and that is because the numbers on the bottom don't go into 100. So what we can do is we are going to do top divided by bottom multiplied by 100. So 6 divided by 37 multiplied by 100. These are quite awkward numbers, so don't expect the percentage to be a nice number. It will have lots of decimal places, which it certainly does. 16.216, etc. percent. The question will tell you how they want the answer, maybe 1 decimal place, maybe the nearest whole number. 6 over 21, that's just going to be 6 divided by 21 multiplied by 100. And 6 divided by 21 times by 100, that is 28.57%. So let's now take a look at ratio. So here we've got a ratio. How do you read this? Well, the colon you say as the word 2. So this is a ratio of 2 to 5. So if I'm sharing some stuff between, let's say, Bob and Anne in a ratio of 2 to 5, that means for every 2 I give Bob, I give Anne 5. 1, 2, 3, 4, 5. If I give Bob another 2, I need to give Anne another 5, and so on and so forth. So for every 2 that Bob gets, Anne gets 5. So by the time Bob gets 6, Anne has got 5, 10, 15. So 6 to 15, that is the same ratio as 2 to 5. So, writing and simplifying ratios. In a cinema, there are 50 boys and 63 girls. Write this as a ratio in its simplest form. Okay, well, since it's been written as boys first and girls second, the ratio will be boys to girls, and that will simply be 50 to 63. It's as easy as that. In the next example, the ratio is 50 to 60. But this ratio can be simplified a bit like the way you simplify fractions. We can divide both these numbers by 10. So we can turn that into a ratio of 5 to 6, meaning for every 5 boys, there are 6 girls. This ratio here is a 3-way ratio, 20 to 30 to 55. And again, it can be simplified because we can divide all of these numbers by 5. So that's going to be 4. 30 divided by 5 is 6. 55 divided by 5 is 11. Probably one of the most common skills you need with ratio is sharing a total in a given ratio. So Bob and Steve are sharing some football stickers in a ratio of 9 to 2. Now, since Bob is mentioned first and Steve is second, then Bob gets the 9 and Steve gets the 2. So what we need to do is turn this ratio into fractions. Now 9 plus 2 is 11. So Bob gets 9 elevenths and Steve gets 2 elevenths. So all we need to do is work out what 9 elevenths of 55 is. So that is 55 divided by 11 times by 9. Take your total, divide by the number on the bottom, times by the number on the top. 55 divided by 11 is 5. 5 times 9 is 45. So 45 is what Bob gets. And now we just need to work out 2 elevenths of 55. So 55 divided by 11 is 5, times 2 is 10. There we go. And we can just do one quick check. 10 plus 45. Oh good, it makes 55. So in the second example, very similar, the ratio is 2 to 1. 2 plus 1 is 3, so one person's getting 2/3, the other person's getting 1/3. So 2/3 of £18,000 is 18,000 divided by 3, which is 6,000, times by 2, which is 12,000. And the second person will be getting 1/3 of £18,000. So that is £18,000 divided by 3, which is £6,000. Quick check, 12,000 plus 6,000 is 18,000, and that was what we started with. So what we're doing here is we are scaling up a ratio. So this is the opposite of simplifying a ratio. So Tom and Sue
bake cupcakes in a ratio of 3 to 5. So T for Tom, S for Sue. And Tom bakes 150. So how many cupcakes does Sue bake? Of course, we're assuming that we are maintaining this ratio. So how many times greater than 3 is 150? Well, 150 divided by 3 is 50. So we've boosted this ratio by 50. So Tom has made 50 times more cupcakes than the given number in the ratio. So therefore we need to do the same to Sue as well. 50 times by 5 is 250. So Sue bakes 250 cupcakes. A recipe requires mixing flour and sugar in the ratio of 2 to 3. So flour to sugar, 2 to 3. This is a very common style question where you're just scaling up a recipe. We've got 600 grams of sugar. Now sugar is the one on the right on this occasion. 600 divided by 3 is 200. So we have 200 times more sugar than the number in the ratio. So in order to make the recipe work, we need 200 times more flour as well, and 2 times 200 is 400. So we need 400 grams of flour. Very similar problem is here we need to work out the total. A drink is made by mixing orange juice and lemonade in the ratio of 3 to 2. If 900 ml of orange juice is used, what is the total amount of drink made? Okay, so we just need to be careful. This is very similar to the previous question, but there's a bit of a catch. It's not a very difficult catch. Here we are multiplying this ratio by 300. So the amount of lemonade we need will be 300 times by 2, which is 600. Now here the answer is not 600, it's the total amount of drink. So the total amount of drink will be the 900 of orange juice plus the 600 of lemonade, giving us a total of 1,500 millilitres. Okay, so nothing new on this question really, it's just making sure that you know to add those two amounts at the end. Okay, so let's take a look at proportion, and there's two types of proportion. There is direct and indirect proportion. On this slide we're dealing with direct proportion, and direct proportion means as one thing increases, the other thing increases as well. So here we're looking at a recipe for bread. So if I increase the amount of flour I add, I need to add more water as well. So let's take a look at this recipe. It's a very basic recipe. Flour is 500 and water is 300. Now, in the first question, we're not using 500 grams, we're using 1.5 kilos, and 1.5 kilos, that is 1,500 grams. Probably a lot easier if we turn this into grams as well. So how many times more than 500 is 1,500? Well, that is 3 times more, and if you're struggling with that calculation, just do 1,500 divided by 500 to get that 3. So we're using triple the amount of flour, so for the recipe to work we need triple the amount of water as well, so that would be 900 ml of water. This next example is fairly similar, although it's a bit of a fiddle. Again, we know that flour to water is 500 to 300, but we want to use 200 ml of water. Now, if you're struggling to go from 300 to 200, well, here you might be thinking, well, what do you divide by to go from 300 to 200? You might want to turn it into what do you do to go from 300 down to 100? So to go from 300 to 100, you would divide by 3. So if I'm using 3 times less water, I need 3 times less flour as well. And 500 divided by 3 is 166.6 recurring. But we don't want 100, we want 200. So 200 is twice the amount that I would use for, well, I'm using twice as much water, so I would need twice as much flour. So I need to multiply the 166.6 recurring by 2, and I get 333.3 recurring. So here the answer would be 333.33 grams of flour. However, the question is asking for kilos, so again, to turn this into kilos, just need to divide that by 1,000, so that would be 0.333 kilos to 3 decimal places. We've not been told what degree of accuracy to leave our answer, but that will be fine. Now here we're looking at indirect proportion or inverse proportion, and what that means is as one value goes up, the other one goes down. So a lot of people will get this first question wrong because a workman takes 3 hours to build a wall. How long will it take one workman? Well, a lot of people will think, well, one workman is 3 hours, so therefore 2 workmen, 6 hours. Of course, that's completely wrong. When you think about the context of the question, you've got more people doing the work, so the work will take less time. So if it takes one workman 3 hours, then if you've got twice the number of people doing the job, then it's going to take half as long. So if it takes 3 hours for one person, then 2 people, of course we're assuming they're working at the same rate, will be 3 hours divided by 2, so 1.5 hours. Okay, let's take a look at this next example. We know that 3 painters take 15 days. How long would it take 5 painters? Okay, well this is a bit of a pain. If it was 6 painters, well that would be nice and easy. That would be double the number of painters, so half the time. So how do I go from 3 to 5? Well, what I'm going to do is we're going to work out how long it would take one painter. So if it takes 3 painters 15 days, then one painter is going to take 3 times as long. So 3 times by 15 is 45. So one painter takes 45 days. So if one painter takes 45 days, then 5 painters, well that is 5 times more people doing the work, so it's going to take 5 times or less time. And 45 divided by 5 is 9. So 5 painters will take 9 days. Okay, so let's take a look at formulas. These aren't terribly complicated, so let's just take a look at a few examples. A taxi company charges £2.40 for every journey plus 40 pence per mile. So what this means is that they always charge £2.40 even if you're only going for a 10-metre journey. It doesn't matter if you're going 10 metres or the length of England, they'll always charge you £2.40. This is the price just for setting foot inside the taxi. So every journey will cost you £2.40 plus however number of miles you do times by 40p. But first of all, let's turn 40p into pounds. So I can write a formula. It's £2.40 plus 40 pence multiplied by the number of miles. And I'll just call miles m. And I can tidy this up. I can say that that's 2.4 plus 0.4 m. So an 8-mile journey will cost 2.4 plus 0.4 multiplied by 8. 0.4 multiplied by 8 is £3.20 plus the £2.40 comes to £5.60. Now for the second example, this is the cost of the journey and this is the formula for the cost of a journey. So therefore I can say that 2.4 plus 0.4 m equals £8.40 or 8.4. Now what I'm going to do is take away 2.4 from both sides. So 0.4 m equals 8.4 take away 2.4. So 0.4 m is 6. And now dividing both sides by 0.4. M is 6 divided by 0.4. So m being the number of miles travelled. 6 divided by 0.4, which is 15 miles. So here are some examples where we've been given a formula. Let's assume, by the way, that we've been told that pi is 3.14. This is the formula for the surface area of a cylinder, where r is the radius and h is the height. We know the radius is 3 and the height is 10. Now 2 pi r squared means 2 times by pi times by radius r times by r. It's only the r that's being squared here, not the 2, not the pi, just the r. Plus 2 times pi times r times h. So that's going to be 2 times 3.14 times 3 times 3 plus 2 times 3.14 times 3 times 10. And you can type all of this in your calculator in one hit because your calculator will automatically follow the laws of BIDMAS and do the adding at the end. And 2 times 3.14 times 3 times 3 plus 2 times 3.14 times 3 times 10. That comes to a total of 244.92, and that is square centimetres. Okay, so here is the formula for the cost of delivering a sofa, where C is the cost of the sofa. So here the cost is 500 plus 0.8 M. M is the number of miles from the warehouse, so here it's 73. So that's all we need to do. Type into our calculator 500 plus 0.8 times 73. If you don't have the confidence to do that in one hit, then do the 0.8 times 73, write it down, and then add 500 to it. And that comes to a total of £558.40. Okay, so moving on to units conversions. Now, there are metric units and there are imperial units. So for length, the metric units are millimetres, centimetres, metres, kilometres. For imperial, they are inches, feet, yards and miles. For weight, metric is grams and kilos, and for imperial is ounces, pounds and stones. And for capacity, or otherwise known as volume, you've got millilitres and litres. And for the imperial, fluid ounces, pints and gallons. Now for the metric units, it's really important that you know, for example, how many millimetres there are in a centimetre. You don't need to know how many inches there are in a yard. If there are any problems with imperial units, then you'll be given the conversion rates. Now for length, you just need to remember that 1 kilometre is 1,000 metres. You also need to remember that 1 metre is 100 centimetres, and you also need to know that 1 centimetre is 10 millimetres. So make sure that you remember those three standard conversions: 1,000 metres in a kilometre, 100 centimetres in a metre, and 10 millimetres in a centimetre. For weight, there's only one that you need to remember, and that is that 1 kilogram is 1,000 grams. So whenever you've got the kil bit, so 1 kilogram is 1,000 grams, 1 kilometre 1,000 metres. Okay, so for weight you just need to remember that there's 1,000 grams in a kilo, and for capacity there's only one you need to remember, which is that 1 litre is 1,000 millilitres. So just make sure you learn these 1, 2, 3, 4, 5 standard conversions, and then you should be good to go on these. Okay, so here we are converting some distance units. So we're converting 8 centimetres to millimetres. So how many millimetres are there in a centimetre? 1 centimetre is 10 millimetres. It's always worth writing this down. So when we're converting from centimetres to millimetres, the number has gone from 1 to 10, we are multiplying by 10. If we were going from millimetres to centimetres, we are dividing by 10. So 8 centimetres to millimetres, we're multiplying by 10, so this is 8 times by 10, so that is 80 millimetres. Here we're going in the other direction, millimetres to centimetres, so we need to divide by 10, and 178 divided by 10, that is 17.8 centimetres. For the next conversion, we need to remember that 1 kilometre is 1,000 metres. So when we're converting from kilometres to metres, we are multiplying by 1,000, and when we're converting from metres back to kilometres, we are dividing by 1,000. So 14 kilometres to metres, we're multiplying by 1,000, so 14 times by 1,000, that is 14,000 metres. 165,000 metres to kilometres, here we are dividing by 1,000, 165,000 divided by 1,000, well 1,000 has 3 zeros, so we can simply just chop off 3 zeros, so that is 165 kilometres. 800 metres to kilometres, again metres to kilometres, we are dividing by 1,000, so 800 divided by 1,000, that is 0.8 kilometres. And 3.2 kilometres to millimetres, okay, a bit of a weird one this one, so what I would do is I would go from kilometres to metres, and then metres to centimetres, and then centimetres to millimetres. So to go from kilometres to metres, we multiply by 1,000, metres to centimetres we multiply by 100, and centimetres to millimetres we multiply by 10. So 3.2 kilometres times by 1,000, that is 3,200 metres. 3,200 metres multiplied by 100 is 3,200 with another 20 on the end, and that is centimetres. And if I just multiply 3,20000 by 10, I get 3,200
0.0000 millimeters. So 3,200,000 millimeters. So for any conversions where you're not going directly from kilometers to meters or meters to centimeters, if you're going kilometers to centimeters, go via the meters first. So here we've got some unit conversions for weight. So the key thing to remember is that 1 kilo is 1,000 grams. So if we're converting from kilos to grams, we multiply by 1,000, and if we're going from grams back to kilos, we divide by 1,000. So 9 kilos to grams is 9 multiplied by 1,000, so that is 9,000 grams. Here we're going grams back to kilos, so that's 1,400 divided by 1,000, and that is 1.4 kilos. 350 grams to kilos, well that is 350 grams to kilos, divide by 1,000, and that is 0.35 kilos. For capacity, again we just need to remember that 1 litre is 1,000 millilitres. So if we're converting from litres into millilitres, we are multiplying by 1,000, and millilitres back to litres, we are dividing by 1,000. So here we're going from litres to millilitres, so that is 6 multiplied by 1,000, so that is 6,000 millilitres. Here we're going from millilitres to litres, so we are dividing by 1,000. 1270 divided by 1,000 is 1.27 litres. And again, millilitres to litres, that is 950 divided by 1,000, and that is 0.95 litres. For a lot of these questions, you just need to make sure you're very confident on how to multiply and divide by 10, 100, 1,000, and how to move decimal points around, which I covered in one of my earlier slides. There is one other very, very easy conversion required for volume, and that is that 1 milliliter is the same as 1 cubic centimetre. So here the number of millilitres is the same as the number of cubic centimetres. So 542 millilitres, well that is simply 542 cubic centimetres. 852 cubic centimetres, that is exactly the same as 852 millilitres. One of the easiest conversions ever, but a lot of people are not aware that millilitres and cubic centimetres is the same number. Okay, so now let's move on to money problems. So here we've been given an exchange rate. £1 is $1.32. So when we're going from pounds into dollars, we are multiplying by 1.32. And if we're going from dollars back to pounds, we are therefore dividing by 1.32. Probably an easier way of looking at this is, well, if £1 is the same as $1.32, then £550 is going to be, well, that is 550 times greater than £1, so we need to multiply the dollar amount by 550 as well. So the calculation is simply $1.32 multiplied by 550. Obviously you need a calculator for this, and 1.32 times 550 is $726. Okay, so here we want to convert the dollar amount to pounds. So again, it is worth seeing it as to go from pounds to dollars, we multiply by 1.32 because 1 times 1.32 is 1.32. So therefore, when we're going back from dollars to pounds, we are dividing by 1.32. So 750 divided by 1.32 is our calculation, and that comes to how many pounds? That comes to a fairly horrible number. That's £568, 0.181818, well, let's just call that, and 18p. Usually in a question, well, if they didn't say, I would round it to the nearest penny, because having more than 2 decimal places isn't very meaningful in the context of money, or they might tell you in the test to round to the nearest pound. Okay, so here we are dealing with some imperial units, and we can see we've been given the conversions here. 1 yard is 3 feet, etc. So if we're converting 75 inches into feet, we are using this conversion here. Okay, so to go from, let me just write this out again. So 1 foot is 12 inches. So if we're converting from feet to inches, we're multiplying by 12. So if we're going from inches back to feet, we are dividing by 12. So this is what we need to do here, is 75 divided by 12, and 75 divided by 12 is 6.25 feet. Ounces to pounds. Okay, if we're going pounds to ounces, we are multiplying by 16. So if we're going ounces back to pounds, we are dividing by 16. So our calculation here is 273 divided by 16, and 273 divided by 16 is 17. Let me just write this underneath so I can write the unit next to it as well. 17.0625 pounds. Gallons to pints. If we're going from gallons to pints, we're just multiplying by 8. So here the calculation is just 13 times by 8, which is 104 pints. And in this final example, we're going 18 stones into ounces. So first of all, let's go from stones into pounds and then go pounds into ounces. If I'm going from stones into pounds, I'm multiplying by 14. So the first calculation is 18 times by 14, which is 252 pounds. And to go from pounds to ounces, I need to multiply this by 16. So 252 multiplied by 16 is the second calculation, and that comes to 4,032 ounces. You can also use conversion graphs to convert from one thing to another. So here we're converting fluid ounces and litres. We can see we've got litres up the side and we've got fluid ounces along the bottom. So for the first question, we're converting 120 fluid ounces. Now the fluid ounces are along the bottom, so I'm going to find 120, which is here, and I'm just going to go up on the line until I hit the line of the graph, which I hit here, and then go across and take a reading, which is this point here. So 3, 3.2, 3.4. So that is 3.4 litres. If I'm doing litres into fluid ounces, then here's 3 litres, so I'm going up the side to 3, going along on this line here with where we've got 3. Ideally, you'd use a ruler, and we're going to go down. So that's 100. Yeah, we might need to check what we're going up in. If we're going up from 0 to 20, and there's 1, 2, 3, 4, 5. 20 divided by 5 is 4, so each line is 4. So 4, 8, 12, 16, 20. Okay, so this is 100. So this line here is 104 fluid ounces. Now here we want to do 47 litres into fluid ounces. Now 47 litres is way off the scale up here. So what can we do? So what I would suggest is look for a nice conversion rate. I mean, we've already got a couple of conversion rates here. We know that 120 is 3.4, 3 litres is 104. But if we look at this point here, this is nice and easy. We can see that 4 litres is the same as 140 fluid ounces. Okay, so what we want to do is work out what 47 litres equates to. Now, it's a bit nasty, this one. If it was 8 litres, well, that's double the number of litres. That would be double the number of fluid ounces. Okay, so what we can do is ask ourselves, well, how many times bigger than 4 is 47? And the answer to that question is, well, what's 47 divided by 4? 11.75. So 4 multiplied by 11.75 will take us to the 47. So therefore we need to multiply the 140 fluid ounces by 11.75 as well. And 11.75 multiplied by 140 is 1645 fluid ounces. So this is how you deal with a problem when you're asked to convert something which is way off the scale. Just find a convenient conversion rate. So normally it's going to be a point where the line goes right through the corner. So for example, this would probably not be a good place to take a measurement, or here, or here, or most of these places really. But here it goes right through the corner of 4 and 140, giving us a really nice conversion rate, which we can use to solve other problems. Okay, let's take a look now at problems involving money. So the first question says that Gary completes an 8-hour shift and earns £96. So what is his hourly rate? Okay, so we know that for 8 hours he earns £96, so therefore for 1 hour that is going to be 8 times less than this amount. So we need to divide 96 by 8. So what is 96 divided by 8? You might need to do a little bus stop method. So 96 How many 8s go into 96? 9 divided by 8 is 1, with a remainder of 1, which we're going to park on the 6 to create a 16. 16 divided by 8 is 2, so his hourly rate is £12 per hour. For the next question, we often see questions like this in exams where the pay rate changes when people work at weekends. So we know that Monday to Friday, the pay rate is £9.50, and it's an additional 20% at the weekend. So how much does she get paid at the weekend? So we need to think about percentage multipliers here. Now, 20%, to calculate 20% of an amount, the multiplier would be 0.2. This number here is the decimal equivalent of 20%. In other words, it's this number here divided by 100. Now, if we want to increase by 20%, we just add 1 to this number here. So 0.2 plus 1 is 1.2. So the weekend rate is going to be 1.2 multiplied by £9.50. And £9.50 times 1.2, that is £11.40. Okay. All right, so Saturday and Sunday, the pay rate £11.40. Okay, so Susan completes 6 hours of work from Monday to Friday. So that's 6 hours for 5 days. So that is 6 multiplied by 5, which is 30 hours of work. So that's going to be 30 multiplied by £9.50. And 4 hours on a Saturday. So that's going to be plus 4 lots of the £11.40, which equals, you might want to do this in 2 instalments, so 30 times £9.50. You could do it in 1 instalment if you trust your calculator, so that's 285 plus 4 times £11.40, which is £45.60. So add the two together and we get a grand total of £330.60. Okay, so moving on now to best buys. So when we're doing best buys, what we need to do is work out the price per individual item, or the price per gram, or the price per kilo, or the price per litre. So in this example here, we've got a 2-pack of Coke for £1.25. So 1 can of Coke is going to be £1.25 divided by 2. So that is 0.625 per can. That would be pence, by the sorry, no, this is pounds, so 62.5 pence per can, but we just leave it as it is for now. So supermarket B sells a 6-pack for £3.50, so 1 can is going to be £3.50 divided by 6, and £3.50 divided by 6 is 0.583 recurring pounds per can. So here we can see that this number is less than 0.625, so therefore supermarket B is better value. Okay, here we're looking at flour. So we know that a 1.5 kilo bag is £1.65 and the 800 gram bag is 89p. So what I would do first of all is turn the 1.5 kilos into grams. So here we've got 1500 grams and that is £1.65. So what you could do is work out the price for 1 gram, but you're going to get a minuscule number because the price of flour is pretty cheap even for 1500 grams. So 1 gram is going to be such a tiny amount, it might make it a bit more complicated. So what I'm going to do is work out what it is for 100 grams. So if 1500 grams is this amount here, then 100 grams is going to be £1.65 divided by 15, and £1.65 divided by 15 is 0.11. So let me just make a note of that. That is 0.11 pounds, and that is per 100 grams. With the other option, 800 grams is 89p, so 100 grams would be 89 divided by 8. So per 100 grams, 89 divided by 8, that is 11.125p. Okay, so which is cheaper? Here we've got 11p versus 11.125p. Well, there's not a lot in it, but we can see that the bigger bag is better value, so the 1.5 kilo bag is better value. Are you looking for further help to pass your functional skills maths course? If so, then head over to our website passfunctionalskills.co.uk, where you'll find full coverage of all the necessary topics with revision videos divided up into 3 key sections using numbers, common measures, shape and space, and handling information and data. You'll also find practice tests, exam style questions, and a full set of mock exams as well. So check out passfunctionalskills.co.uk. Okay, moving on to interest and compound interest. So here we know that Geraldine is investing some money in a bank account and it's giving her 5% interest a year. So what that means is that Geraldine's bank balance is going to increase by 5% per year. Now the multiplier for 5% is 0.05, so that is the multiplier just for 5% when you're trying to work out 5% of an amount. So what we could do is we could work out 5% of this figure here and then add it on. However, we could apply a different multiplier, which is the multiplier for a 5% increase, and that is 0.05 plus 1, so 1.05. It's really worth trying to get to grips with understanding how these multipliers work when you're dealing with percentages. So here the calculation is 1500 multiplied by 1.05, and 1500 times 1.05 is £1,575. There we go. Another way you could do it, as I say, 10% is 150, so 5% is half of that, which is 75. Add 75 onto the 1500, you get 1575. Okay, so in the next example, we're talking about simple interest. Now, most banks don't do simple interest, they do compound interest. Here what it means, well, simple interest is it's the same interest amount every single year. So we've already worked out from the previous example that the interest is £75. So 3 years later, it means Geraldine will get an extra £75 plus another £75 plus another £75. So 3 lots of £75. 75 times by 3 is 225. So the total interest she receives is 225 on top of the 1500. So 1500 plus the 225 comes to 1725. Now the next example, this is compound interest. So it's not going to be the same amount of interest each year. Every year she will gain interest on the previous year's interest as well. Now what we need to do, we really can't get away with not understanding multipliers for this question. So after 1 year, the calculation is 1500 multiplied by 1.05. For the second year, we're going to multiply it again by 1.05, and for the third year, we'll multiply again by 1.05. Now, a lot of people will do what 1500 times 1.05 equals, and then type that number back in, times 1.05 equals, but actually you can do it in one hit. 1500 times 1.05 times 1.05 times 1.05, or even better, 1500 times 1.05 to the power of 3, because it's 3 years. If it was 7 years, it'd be to the power of 7, etc. So 1500 times 1.05 to the power of 3, and that gives us a new bank balance of 1736. To the nearest penny would be 0.44. Okay, so here we've got an interest rate, quite a steep interest rate, 12%. So each month this amount is being increased by 12%. Now the multiplier for 12% is 0.12, but for a 12% increase, the multiplier is 1.12. So I'm going to multiply £1,300 by 1.12, and this is the interest rate per month. So this is after 4 months. So we can either multiply by 1.12 times 1.12 times 1.12, or much more, much less effort would be 1300 times 1.12 to the power of 4, and 1300 times by 1.12 to the power of 4 is £2,045 and 58p, rounding to the nearest penny. Okay, so here is another example, but exactly the same thing, but the interest rate is a bit of a fiddle. Now, the multiplier for 4.1%, if it's not obvious, divide this by 100. 4.1 divided by 100 is 0.041.
So this would be the multiplier used to work out 4.1% of an amount, but if you want to increase by 4.1%, then add 1.041. So here the calculation is £25,000 multiplied by 1.041, and this is going to be to the power of 5, or just type in times 1.041 times 1.041, total of 5 times. So I think it's a lot easier if we use these powers. £25,000 times 1.041 to the power of 5 comes to a total of 30,562.84p to the nearest penny.
Moving on to speed, we need to learn the formula that speed is distance divided by time. If we flip these two elements around, then time is distance over speed, and speed multiplied by time is distance. Hopefully, if you just learn speed is distance over time, then if you've got some basic skills on how to rearrange an equation, then you can work out the other two. Okay, so what's the car's average speed? Well, speed is the distance divided by time. So that's 87 kilometers divided by 3 hours, and 87 divided by 3 is 29. Now, since the distance is in kilometers and the time is in hours, then this is kilometers per hour. The next one, we want to know how far, so the distance, so that is speed times by the time. So that's going to be 45 multiplied by 7, and 45 times 7 is 315, and since the speed is in miles per hour, then this is 315 miles. For the next one, how long does the journey last? So this is time, so time is the distance divided by the speed. Now the distance is 360, the speed is 72, and 360 divided by 72 comes to a total of 5. So that is 5 hours. Okay, moving on to the next set of questions. Here it's slightly harder because we've got hours and minutes. So we know that speed is the distance divided by time, so that's 123 divided by, how do we do 5 hours and 30 minutes? Well, think about 30 minutes. 30 minutes, that is half an hour, and a half is 0.5. So 5 hours and 30 minutes is 5.5, not 5.3, which is what some people might be tempted to write. So 123 divided by 5.5, that comes to something quite nasty. The average speed is 22.363636. This seems to be a recurring 2 digits. In a test, they would tell you how they want the answer presented. The next one, we want how far does the car travel? Well, if speed is distance divided by time, then speed times by the time is the distance. So the speed is 65 and the time is 3 hours 15. Now 15 minutes, think about that, that is 1/4 of an hour, and 1/4, that is 0.25. Worth knowing that a quarter is 0.25. If you don't know that, then just do 1 divided by 4. So although the chances are that if you don't know that a quarter is 0.25, you probably don't know that 1 top divided by bottom will give you the decimal equivalent. So 3 hours and 15 minutes, that is 3.25. So 65 multiplied by 3.25 comes to 211.25, and since this was in miles per hour, then this is miles. Sorry, I should have put for the previous one the unit for the speed. This is kilometers, so this is kilometers per hour. Okay, the next one, how long does the journey last? Well, if speed is the distance divided by time, these two can be flipped over. Time is the distance divided by the speed, so the distance is 216 and the speed is 62, and 216 divided by 62 is 3.48387, and this is hours. Now you might be asked to put this in terms of hours and minutes. Now I know a lot of people will think that that is 3 hours and 48 minutes. Unfortunately not. You could do a calculation where your calculator might say 3.95. That couldn't possibly mean 3 hours and 95 minutes, because 95 minutes is greater than an hour. The calculator uses the decimal system, so it's counting up to, it's counting in tens and hundreds. So it doesn't know that we're doing time, and therefore it doesn't know that there's 60 minutes in an hour. Now, what we've got here is we've got 3 full hours. So that's going to be 3 hours. And what we've got left after the 3 hours is, if I take away the 3 hours, I've now got 0.48387 of an hour. Now, we know that 1 hour is 60 minutes. So if I'm converting from hours into minutes, I multiply by 60. So if you've got this number typed on your calculator, take away the 3. Take away the 3 and you've got 0.4838709,677, and now multiply that by 60 and you've got this in minutes, and you've got 29.03. So we'll just call that 3 hours and 29 minutes to the nearest minute. I doubt in an exam that they would be interested in the seconds after that. So be careful when you get a decimal answer. It's quite easy if you get a 3.5, you know, hopefully that's 3.5 hours, or if you get a 4.25, that's 4.25 hours, so 4 hours and 15 minutes. You might get a 5.75, which is 5 3/4 of an hour, so 5 hours and 45 minutes. But if you get a nasty one, then remember, take away the whole number and then multiply this by 60 to turn the fraction of an hour, or the decimal equivalent of the fraction of an hour, into minutes.
So for density, we need to remember that density is the mass over volume. Again, doing the little swapsy, volume is mass over density, and density times by the volume is the mass. Just learn one equation and just make sure you can switch it around to make anything else the subject. Okay, so again, we need to make sure the units are consistent. If we want the density in kilos per cubic meter, we need the mass in kilos and the volume in cubic meters, which we do, so no problem at all. So density is the mass divided by the volume. So here the density is 3.5 divided by 1.5. So grab a calculator, 3.5 divided by 1.5, the density is 2.3 recurring kilos per cubic meter. Okay, so this is what I mean about making sure the units are consistent. If we're giving the density in grams per cubic meter, the volume must be cubic meters and the mass must be grams, but it's not, it's kilos. So multiply this by 1000, we've got that in now in grams. So the density is the mass over volume. So the density is 8,200 divided by 1.5, and 8,200 divided by 1.5 is 5466.6 recurring, and again that is grams per cubic meter, because this was grams and this was cubic meters. Okay, so density is the mass over volume. Do the little swapsy. Volume is mass over density. So again, let's just double check we've got the units aligned, kilos and kilos. So the mass is 8.7 and we're dividing that by 2.4. 8.7 divided by 2.4 tells me that the volume is therefore 3.625, and that is going to be cubic meters. Okay, again, cubic meters, so that's all good. And we want the mass. So density is the mass divided by the volume. So density times by the volume is the mass. So the density is 2.4 multiplied by a volume of 1.2, and 2.4 times by 1.2 is 2.88. And since this is kilos per cubic meters, this would be kilos and not grams. Moving on now to perimeter. Now it's really important that you don't confuse perimeter and area. Area is the bit in the middle, perimeter is the bit around the outside. So if we're told that A, B, C, D is a square, you only need to be given one side, because one of the key properties of a square is that each side is the same length. So this is 11 centimeters, this is 11 centimeters, this is 11 centimeters. So the perimeter is 11 plus 11 plus 11 plus 11, or 4 times by 11, so that is 44 centimeters. Here we've got a rectangle, and one of the key properties of a rectangle is that opposite sides are equal in length. So this is also 15 centimeters, and this is 5.5 centimeters. So the perimeter is all of the 4 sides added together, so 15
plus 15 is 30, 35.5, 36 plus 5, which is 41 centimetres. Another way you could do it is you could see it as 15 plus 5.5 and then double that answer, or just add them all up individually to play it safe. You could be asked to work out the perimeter of a more complicated shape. So here we can see it's simply, well, 6 plus 3 plus 4 plus 7. 6 plus 3 plus 4 plus 7. So there's 10 and there's another 10. So far we've got 20 centimetres, but we need to work out ED and DC. Well, let's have a look at DC first. If it is 6 centimetres from here to here, and it's 4 centimetres from F to E, then 6 take away 4 must be this distance here, which is the same as DC. So 6 minus 4 is 2, so that's 2 centimetres. A similar method for working at ED. B to C is 7, and A to F is 3, which is the same as this distance here. So if this is 3 and this is 7, 7 take away 3, this must be 4. So with the labelled sides, I've got 20 plus 4, 24, plus 2 is 26. So the perimeter is 26 centimetres. So when you're faced with a problem like this, yeah, make sure you do account for any unlabelled sides. Okay, moving on now to area. So the area of a square, nice and easy. Again, you only need to be given one side length because every side is the same. Now the formula for the area of a square and a rectangle is the length times the breadth. So here it's just 11 multiplied by 11, which is 121. Because you're multiplying a number by itself, the area of a square is always a square number. That's why they're called square numbers. Exactly the same for a rectangle. It's one dimension multiplied by the other, or the length times the width. So 5.5 multiplied by 15, and 5.5 times by 15 is 82.5. Now I have neglected to mention the units here. Perimeter, or a side length, is centimetres. The perimeter is also a distance, which would be centimetres, but for an area, centimetres times centimetres is centimetre squared. So for area, the units are always squared. So we need to remember that the formula for the area of a triangle is a half of the base times by the height. So if we've got a base here which is 12 centimetres and we've got a height which is 10 centimetres, then the area of this triangle here is a half of 10 times by 12. You can do a half of 10, which is 5, 5 times 12 to get 60, or you could do a half of 12, which is 6 times 10, which gives you 60, or 10 times 12, 120, half that, it's still 60. So 60 square centimetres. You could be confronted with one of these compound shape problems, and to solve these, what you really need to be doing is turning it into we definitely need to turn it into two rectangles. So it's just a question of whether you're going to make the cut horizontally or vertically. It depends on what they've given you so far. So looking at this side length here, this is 12.5. If this from here to here is 10, then this distance here is going to be 12.5 take away 10, so that is 2.5. So this rectangle here is 2.5 times by 5, and 2.5 times 5 is 12.5. So this area here is 12.5 square metres, and what we need to do now is just work out the area of this rectangle here. Well, it's 12.5 along the bottom, we just need to work out this side length here. Well, we know it's 7 metres from top to bottom and 5 metres from here to here, and so therefore 7 take away 5 is 2, so this is it's not centimetres, it's metres, and 2 times by 12.5 is 25 square metres. So the area of the whole shape is 12.5 square metres plus 25 square metres, and that is 37.5 square metres. So again, with compound shapes, turn it into two rectangles, work out the area of each rectangle separately, because there's no magic formula for the area of an L-shaped shape. Are you looking for further help to pass your functional skills maths course? If so, then head over to our website passfunctionalskills.co.uk, where you'll find full coverage of all the necessary topics with revision videos divided up into 3 key sections: using numbers, common measures, shape and space, and handling information and data. You'll also find practice tests, exam style questions, and a full set of mock exams as well. So check out passfunctionalskills.co.uk.
Let's take a look now at circles. So the perimeter of a circle, so if you're going all the way around the outside edge, that is called the circumference. So the perimeter of a circle has a special name, it's called the circumference. If you draw a line from one side of a circle to the other and it passes through the centre, then this is a diameter. And if you draw a line from the centre to the edge, or to the circumference, then that is a radius. Okay, and the key thing to remember is that a radius is half of a diameter. From the centre to this point here, this is a radius. And from here, going the other way, I've got another radius. So here we can see that 2 radiuses is the same as a diameter, and that's definitely worth remembering. Okay, now you need to remember the formula for the area of a circle, which is pi r squared. Now your calculator might have a pi button on it, or you might be told that pi equals 3.14, in which case just use the number 3.14. So pi r squared means pi times by the radius times by the radius. Now remember that the radius is the distance from the centre to the edge. So here the radius is 2.9. Sometimes they give you the diameter, so be careful. So here we would need to do 3.14 multiplied by 2.9 multiplied by 2.9. And obviously we'd need a calculator for this. And you could type in 2.9 squared if you really wanted to. And that will give you a total of 26.4074. And this would be, because it's area, it would be centimetre squared. Here's another area problem, and here we've been told that the diameter is 11.3. Now the formula for the area of a circle is pi r squared, so pi times the radius times by the radius. Let's assume we've been told that pi is 3.14, so it's 3.14 times, now don't think the radius times the radius is 11.3. The radius is half of 11.3, so the diameter is 11.3, so therefore the radius is 11.3 divided by 2, and 11.3 divided by 2 is 5.65. So this is the calculation: 3.14 times 5.65 times 5.65, and 3.14 times 5.65 squared comes to 100.23665, and again that would be square centimetres. Moving on now to circumference, there's a different formula for the circumference, which is 2 pi r. That means 2 times by pi times by the radius. Again, let's assume we've been told that pi is 3.14, so 2 times 3.14 times the radius, which we can see is 8.6. So grab your calculator, 2 times 3.14 times 8.6, and that comes to 54.008. And the circumference, that is the distance around the outside. So that is centimetres, it's not centimetre squared, because that will be for the area. Okay, let's do another example. So again, the formula for the circumference is 2 pi r, so 2 times pi times by the radius, and let's assume we've been told that pi is 3.14. Now, what you could do, we've been told that the diameter is 11.3, and 11.3 needs to be halved, so that we've got the radius. So the radius is 5.65. So it's 2 times by pi times by 5.65. Now, I don't want to confuse the issue, but we've just halved 11.3 to give us 5.65, and now we're just going to double it again. So actually what we could have done is just do 11.3 times by pi. So there is actually another formula. Again, I find it hard to resist not giving students both formulae. 2 times the radius, well, if you're doubling a radius, you get the diameter. So
you can use this formula as well, pi times the diameter. But if any of this confuses you, then just stick to the 2 pi r. But a quick way would have just been 11.3 times by pi, or times by 3.14, and we would get 35.482 centimetres, which of course is the same as doing 2 times 3.14 times 5.65. Moving on now to 3D shapes. So we've seen 2D shapes, two-dimensional shapes. Two-dimensional shapes have 2 dimensions. In the case of this rectangle here, we've got a height and a base, or a length and a width. There's only 2 dimensions, whereas on a 3-dimensional shape, we've also got depth as well. So the front face of this 3-dimensional shape is a rectangle, which is 2-dimensional, but then this rectangle is extending backwards, and so we've got this 3rd dimension, which is its depth. So remember that 3D shapes have 3 dimensions and 2D shapes have 2. Now there are certain 3-dimensional shapes that we need to remember. So on the left we have a pyramid, but also on the right hand side we've got a pyramid as well. So we can't just go around just chucking around the word pyramid at random. We need to say what type of pyramid it is. So this pyramid here has a triangular base. So this is simply a triangular based pyramid, whereas the one on the right here, well, this is a square. So this is a square based pyramid. To the right of the triangular based pyramid we have a cube. Normally they would indicate that all these dimensions are identical with some dashes, or perhaps in the words it would say that they're all the same length, these edges. To the right of that, so a cube is a square, all the faces are squares, whereas here we've got a rectangular front face, so this is not a cube, this is called a cuboid. Other 3D shapes you need to memorize. Here we have, this one here is called a triangular prism. And what a triangular prism is, it's a triangle front, and it's basically a triangle all the way through. If I was to saw through the middle here, then I would still expose another triangular face. Now, to the right of the triangular prism, we have, this is a cylinder. To the right of the cylinder, we have a cone. And here, this ball shape, this is a sphere. So these are the 3D shapes that whose names you need to memorize. Moving on now to the volume of 3-dimensional shapes. Here we have a cube. Now, in order to work out the volume of a cube, all you need is to know the length of one of the edges. So let's say that it is 4 centimeters across. Now, because we have been told it's a cube, then it means that the height is also 4 centimeters and the depth is also 4 centimeters. The volume of a cube is simply the 3 dimensions multiplied together, so 4 times by 4 times by 4, 4 cubed, in other words, and 4 times by 4 times by 4 is 64. Now, if the length is in centimeters, then the volume will be in cubic centimeters. And the volume of a cube is always a cube number, because you're multiplying a number by itself 3 times, and when you multiply a number by itself 3 times, you get a cube number. Now onto the volume of the cuboid. Again, nice and easy. It's just the 3 dimensions multiplied together. So here it's just 5 centimeters multiplied by 18 centimeters multiplied by 8 centimeters, and 5 times 18 times 8 is 720. So that is 720, and again the unit is cubic centimeters. Okay, so now we are looking at the volume of this triangular prism. Now, another way of working out the volume of any object, provided it's a prism, and when I say a prism, that means it has to have constant cross section. So, for example, a cube is a square all the way through. This cuboid is a 5 by 18 rectangle all the way through. It doesn't matter where I chop it. If I saw across it, I'll still expose a 5 by 18 rectangle, if I saw it perfectly, of course. So this is a triangle all the way through. Now, the volume of any prism is the area of the front face multiplied by its depth. So, for example, what we could do here for this for the cuboid is let's work out the area of this front face here, and 5 times 18 is 90, so 90 square centimetres, and multiply that by its depth, and 90 times by 8 gives us the 720 cubic centimetres that we worked out before. But I explained it as just multiply these three numbers together. But of course, if you multiply these two numbers together, you get the area, and then multiply it by 8 is exactly the same thing. Similarly, if you've got a cube which is 4 by 4 by 4, then the area of the front face is a square which is 16 square centimetres, and then multiply it by the depth, which is 4 centimetres, so 16 times 4 gives you the 64 cubic centimetres. But I presented this as just multiply 4 by itself 3 times. For a more complicated one though, like this triangular prism, then I would see it as what is the area of this front face multiplied by its depth. So here the depth is 3.5, we'll worry about that in a minute. The area of the front face, well, this is a triangle. Now the formula for the area of a triangle is 1/2 base times height. So 1/2 times by 6 times by 5. Half of 6 is 3 times 5 is 15. So the area of this face here is 15 square centimetres. So area of front face times depth, so 15 multiplied by 3.5, and that gives me the volume of the prism, which is 52.5 cubic centimetres. So just to recap, probably for a cube and a cuboid, then you just want to be multiplying the 3 dimensions by each other. For a more complicated shape, work out the area of the front face, multiply by its depth. Here we have a cylinder, and again I would recommend thinking of it as it's the area of its face. Now the area of the face is a circle, and the area of a circle is pi r squared multiplied by its height. So if you wanted just to learn the formula for the volume of a cylinder, then it's pi r squared h, and the reason why it's area of its face multiplied by its height. So let's say, for example, we know that this has a radius of 5 centimetres and it's got a height of 20. Then let's work out the area of the face. So circular face, that's pi r squared, which is 3.14 times 5 times 5, and that is 78.5. So the area of the face is 78.5 square centimetres. Yeah, I did say it was centimetres. So now the volume is going to be 78.5, the area of the face multiplied by its height or its depth, however you want to describe that, 78.5 multiplied by 20, and that comes to 1,570 cubic centimetres. Okay, so let's take a look at a question where we're using length, area and volume in calculations. So the diagram shows Chris's back garden. His patio is a square and his pond is a circle. Chris wants to lay some new turf down in his back garden. The turf costs $2.75 per square metre and can only be bought in square metres. Calculate how much it's going to cost Chris to turf his back garden. Okay, so what we need to do is work out the area of this green bit here. Now, what makes this initially quite complicated is the fact that the grass just goes beyond this point here. So what we need to do is work out the area of this small rectangle here. Now it's going to be 2.3 metres across because this side length will be the same as the 2.3 here. We know this is a square. What I'm going to do first of all is work out this distance here. Now from this point here to this point here it's 5.4, and from here to here is 2.9. So the distance from here to here is going to be the difference, which is 5.4 minus 2.9, and that is 2.5 metres. So this is 2.5 metres. Now I know that because this is a square that this is 2.3 metres, so the difference between 2.5 and 2.3, I'll just write it down to be on the safe side, 2.5 take away 2.3 is 0.2 metres. So this is a rectangle here which is 2.3 across and 0.2 down. So the area of this rectangle is 2.3 multiplied by 0.2, which is 0.46 square metres. So I'll just draw a little arrow to show that that is the area of that part there. Now this big rectangle, that's a bit easier, that's going to be 2.9 multiplied by 8.3. and 2.9 times 8.3 is 24.07 square metres. So that's this bit here. Now obviously, well, I say obviously, we need to subtract the area of the pond. But first of all, I'm going to work out the area of the whole green bit combined, and that will also include the circle. So that's going to be 24.07 plus 0.46, and that comes to 24.53 square metres. Now what I need to do now is do 24.53 square metres minus the area of the circle. So this is the final thing we're going to do. Actually, it's not the final thing, because then we need to work out the price. Now the formula for the area of a circle is pi r squared. So that's going to be pi, which we've been told is 3.14, multiplied by the radius. Now be careful, we've been given the diameter. So if the diameter is 1.1, then the radius is 1.1 divided by 2. So here the radius is going to be, might need a calculator for this, 1.1 divided by 2 is 0.55. So r is 0.55. So our calculation is 3.14 times 0.55 squared, and 3.14 times 0.55 times 0.55 comes to 0.94985. So this is the area of the pond. So we need to subtract that from the 24.53. So 24.53 take away 0.94985, and that comes to 23.58015 square metres. Now we know it's £2.75 per square metre, and we can only buy a full square metre at a time. So we're going to have to round that to 24 square metres, not because it's closer to 24 than 23, but just because it's slightly more than 23. 23 square metres will not be enough coverage, there'll be this bit uncovered, so that's why even if it was 23.005 for example, we'd still need 24 square metres. So it's going to be 24 square metres multiplied by £2.75, and 24 times £2.75 comes to £66. So that's the final answer. That's how much it's going to cost Chris to turf his back garden.
So let's take a look at nets. Here is a cube. If we were to fold out a cube, we would see 6 squares. Each face of a cube is a square, and a cube has 6 faces, so 6 squares. But not any combination of 6 squares will make a net of a cube. However, all of these are correct nets of cubes. If you just imagine we were doing some origami and just making folds along let's take a look at this first example. If I made folds here, 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 and here, and I called this the front, then this would be the top, this would be the base, this would be the right hand side, and this would be the left hand side, and another fold here, this would be the back. Now, a net of a cube can be 4 squares in a row, and 1 square on the top and 1 on the bottom. Now this square on the top can be anywhere on the top, and the one on the bottom can be anywhere on the bottom. So it could look like the second example here or the third example here. Again, we could have 1 square here and 1 square here. It doesn't matter, as long as there's 4 in a row, 1 on the top, 1 on the bottom. This is another way that we can make a cube. This is a correct net of a cube. Not quite so obvious, but again, if you just imagine you do the origami, this will turn into a cube. But if you were asked to draw a net of a cube, I would keep it simple and just do the sort of cross shape, 4 in a row with a square on the top and a square on the bottom. So here are some other nets. So again, imagine we were just doing some origami and folding down these lines here, and we called this the front, then this would be the top, this would be the left hand side, this would be the right hand side. Another fold here would mean that this is the back, and another fold here would mean that this is the base or the bottom. Sorry, call that the back, B for back and this B for bottom. And what we would have is a cuboid. There we go. So this is the net of a cuboid. And again, this square could be anywhere on the top and this square could be anywhere on the bottom. It doesn't matter. Okay, so what do we have here? Again, if we do imagine we're doing some origami and do some folding, we could call this the base, and we will call this the top. And if we were to fold along here, then this line, this edge of the rectangle would align perfectly on this edge of the triangle. And if we were to fold along here, then this edge would rest on this edge of the triangle here. So what we would end up with is basically, if you can imagine, a Toblerone box. And again, if we just do a little fold here, then these edges of this triangle will sit perfectly on these bits here. What we've got is a triangular prism. So remember, a prism is a shape that has a constant cross section. So this is a triangular prism because the constant cross section is a triangle. Wherever we saw it, we will just create triangles throughout. Okay, so this is a slightly easier net because we don't have very many options. We can only do folds here, 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 and here. And if we fold all of these triangles together, they will all come together, all the tops of the triangles will come together, and that will form a pyramid. And in particular, this pyramid is one with a square base. So this is the net of a square-based pyramid. Here, this one's a bit more complicated. Again, if we were to fold this down and fold this up, and then curl this this edge around the circumference of this circle and of the circle on the bottom, then what we would have is a cylinder. So whenever you've got a rectangle with a circle on the top and a circle on the bottom, then this is the net of a cylinder. And again, the circle can be anywhere on the bottom and anywhere on the top. It can't be on the sides, and they can't both be on the top, and they can't both be on the bottom. So one has to be on the top, one on the bottom. So this is the net of a cylinder. Moving on to surface area. So what is the surface area of this cuboid? So first of all, we need to think, well, how many faces does it have? It has 6 faces. Of course, we might not be able to see more than 3 because we're seeing it on 2-dimensional paper or on a screen. But sometimes they put in these lines to give the effect of 3D, and then it's a bit more obvious that there are more faces than meet the eye. So what we need to do is just, I would say for a cuboid, I would deal with it in stages. So first of all, let's work out the surface, the area of this rectangular front. So this is 8 by 3. This is a height of 3, so this is a height of 3, so this is a height of 3. Don't know why I wrote 8. So the area of the front is 8 times 3. But there is a front and there is also a back, which is identical. So let's just rewrite that as front and back. So that is 8 times by 3 times 2, because there's 2 of them. Let's do the same now with the sides. We've got a side here 5 by 3, but this right hand side and the left hand side will be the same, so it's 5 times 3 times 2. Now you've also got a top and a bottom. Now the bottom is 8 times 5, so the top is also 8 times 5, so we've got 2 8 by 5s. 8 multiplied by 3 times by 2 is 48. 5 times 3 times 2 is 30, and 8 times 5 times 2 is 80. So the surface area is the area of all of these added together. So 30 plus 80 plus 48, and that comes to 158 square centimetres. So always deal with it in pairs. Deal with the right hand side and the left hand side together, the front and the back together, and then the top and the bottom together. What about the surface area of a cylinder? Okay, so what we've got first of all is we have a circle and we have another circle. Now what is the formula for the area of a circle? It is pi r squared. Well, we've got 2 of them, so that is 2 pi r squared, and here the radius is 4. Now what about this curved surface area? Now the next time you have a used toilet roll, just cut it or just rip it and then fold it flat. And when you fold it flat, you'll see it turns into a rectangle. So if I were to cut down here and fold this flat, I'd have a rectangle which is 5 centimetres, and the other measurement would be the circumference of a circle. Now the formula for the circumference of a circle is 2 pi r. So if you want to learn the formula, you could learn it as 2 pi r squared plus 2 pi r times, well in this case it's 5, but the height is not always 5, so we'll just call it h for height. So that is a formula you might want to learn. But it's fine, or it's probably preferable in my opinion, instead of just learning this random bit of information. Think about it, it's 2 circles plus a rectangle, which is the height of the cylinder multiplied by the circumference of the circle. So for this particular example, again, let's assume we've been told that pi is 3.14. 2 times by 3.14 times 4 times 4 plus 2 times 3.14 times 4 times the height, which is 5. And again, you can work these bits out separately and then add them together, or type it straight into your calculator, because most good calculators will use BIDMAS. So 2.3.2 times 3.14 times 4 times 4 plus 2 times 3.14 times 4 times 5, and that comes to a grand total of 226.08 square centimetres. Okay, so plans and elevations. So we have the plan view. Now the plan view is the view from above, so a bird's eye view. If you were flying over the top of this shape, what would you see? So what would the plan view be? So if you were up above looking down on this shape, all you would see is this square here, this square here, this square here, and this square here. So the plan view would be one square, this square here, another square underneath that, another square underneath that. So these 3 squares are these 3 here, and the bottom one would have one coming off to the side. So this would be the plan view. Now there are 2 elevations. There's the side elevation and the front elevation. We've been told that this is the side, so if we're viewing from the side, then all we're going to see is this square here and this square here. So the side elevation would simply be 2 squares like so, and the front elevation would simply be, well, this square here, and this square here, which would be 3 in a row like so. Here's another example. So again, let's have a look at the plan. So that is going to be the view from above. So from above, we're only going to be seeing these darker pink squares, which would be a bit of a, well, that's funny cross shape. So one in the middle and one coming off each side like so. The side elevation, if I'm looking at this from the side, then I would see this square here, and this square here. So that would just be 3 squares in a row like so. And from the front, all I would see is this square here, and this square here. So the front elevation would look exactly the same as the side elevation, which is to say 3 squares in a row. Okay, so on to maps and scale drawings. Now, whenever you've got questions involving maps and scale drawings, you are given the scale. So you could get a scale where you've been told 1 centimetre equals 100 metres. Well, of course, 1 centimetre does not equal 100 metres, but what this means is that 1 centimetre on the map, or on the grid, or on the picture, that represents 100 metres in real life. You could be given it in the form of a ratio, 1 to 10,000. So what that would mean is that 1 unit on the map, so 1 centimetre or 1 millimetre, would represent 10,000 centimetres or 10,000 millimetres in real life. Sometimes, this is probably the easiest one to understand, you've just got an arrow between 2 lines and you're told that that is 100 metres. So if that is 100 metres, then the distance from here to here would be 100, 200, 300, 400 metres, nice and easy. Okay, so for this question, we need to work out the real life distance between A and B. Now, we've been told that this distance here is 5 kilometres. So what we need to do is measure how far it is from A to B using a ruler. Now, A to B, we can see is 8.5 centimetres. And if we measure the scale, we can see that this distance here is 1 centimetre. So what we know is that 1 centimetre equals 5 kilometres. So if 1 centimetre equals 5 kilometres, then 8.5 centimetres is going to equal 8.5 multiplied by 5, and 8.5 times 5 is 42.5 kilometres. So A to B using the ruler is 8.5 centimetres, but in real life it's 42.5 kilometres. So for this question, we've been told that the real life length of the car is 3.2 metres. In the picture, it's 8 centimetres, and we need to work out what the scale is. Well, the scale is simply 8 centimetres to 3.2 metres. Now, probably the easiest thing to do is to get rid of the fact that we've got a discrepancy of units. We've got centimetres and metres. Let's turn them both into centimetres. So 8 centimetres to 3.2 metres, multiply that by 100, is 320 centimetres. So the scale as a ratio is 8 to 320. But this can be simplified. We can divide both of these numbers by 2, so 4 to 160, divide by 2 again, 2 to 80, and then 1 to 40. So the scale as a ratio in its simplest form is 1 to 40. So what that means is 1 centimetre on the scale represents 40 centimetres in real life. 1 inch on the scale represents 40 inches in real life. So the scale is 1 to 40. Using a scale of 1 to 50, draw a scale drawing of a rectangle measuring 4 metres by 3 metres. Well, we have to scale it down, obviously. We're not going to scale it up because that would be crazy. 4 metres by 3 metres is already pretty large. Now, this scale 1 to 50 means that the real life is 50 times bigger than the scale drawing. So what we need to do is we are scaling this down, so we need to make these measurements 50 times smaller. Now, probably the easiest thing to do is turn them into centimetres, so that is 400 by 300, and so our scale drawing will be 400 divided by 50 by 300 divided by 50. 400 divided by 50 is 8. 300 divided by 50 is 6. So we need to do an 8 by 6. So 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I should have mentioned, of course, we know that each square is a centimetre square. So that is 8 across and then 6 down. 1, 2, 3, 4, 5, 6. So there we go. There obviously it'd be better if you could use a ruler, but there we have it. There is a rectangle. There is a 1 to 50 scale drawing of a rectangle measuring 4 metres by 3 metres. Coordinates is quite an easy thing to get right. You just need to remember it's horizontal then vertical. At schools we normally teach children go along the corridor and up the stairs. So for B, what are the coordinates of B? Well, we're going along to 4 and up to 1. So the coordinates for B is 4, 1. For A, we're going along to -3 and then down to -3. So that is -3, -3. That one's quite easy because you can't really get them the wrong way around because they're both -3. Sometimes in the question they might say something like plot point C to create a right angled triangle ACB. What are the coordinates of point C? Now if I were to make a right angled triangle, I would have to put C here, and there, that would give me my right angled triangle. And the coordinates of C, well, that's along 4 and down -3, 4, -3. Of course, C could also be up here. We could also create a right angled triangle like so. And the coordinates for C, well, they could be 4, -3, but they could also be -3 plus 1. So sometimes you get questions where you have to plot a coordinate to make a shape and then state what the coordinates are. But don't forget, horizontal, then vertical. Let's take a look at angles in two-dimensional shapes. So on the left-hand side, we have a three-sided shape, otherwise known as a triangle. And we need to remember that angles in a triangle always add up to 180 degrees. So therefore, A plus B plus C, or angle A plus angle B plus angle C equals 180 degrees. On the right hand side, it looks like a parallelogram, but the key thing to remember, it's a four-sided shape, and four-sided shapes, otherwise known as quadrilaterals, have interior angles that add up to 360 degrees. So angle A plus angle B plus angle C plus angle D equal 360 degrees. Nice and easy. So remember, triangle always adds up to 180 and a four-sided shape always adds up to 360 degrees. So here we have two triangles. Now we know that triangles have angles that add up to 180 degrees. Now the triangle on the left is a right angled triangle. So this angle here is a right angle. Whenever we get this square in a corner, that denotes a right angle, and a right angle is 90 degrees.
So we know 2 out of the 3 angles. The angles we know are 90 and 50. And 90 degrees plus 50 degrees is 140 degrees. So angle X must be the difference between 140 and 180. And 180 degrees take away 140 degrees is, of course, 40 degrees. So this angle here is 40 degrees. Now, on the right-hand side, we've got a special type of triangle. This is an isosceles triangle. And there are 2 key properties of an isosceles triangle. The first one is that it has 2 equal sides. These dashes show that this side here and this side here are equal. And the other key property is that the base angles are the same. So the angle on the left here is the same as the angle on the right. We can work out what these angles are because they're the same. The angles of any triangle add up to 180. So if I take away the 70, I'm left with 110 degrees. And since these 2 angles here are identical, all I need to do is divide 110 by 2. And that tells me that each angle is 55 degrees. And if you're not confident with that, then just add up 55 plus 70 and you'll get 180. So let's assume for this question we need to work out this angle here, angle A. It's a 4-sided shape, so the angles are going to add up to 360 degrees. So what have we got so far? We have 120 degrees, we have 80 degrees, and we have a right angle. And hopefully we remember that a right angle is 90. So if we add these together, 120 plus 80 is 200. 200 plus 90 is 290 degrees. So angle A is going to be the difference between 360 and 290. 360 degrees, take away 290 degrees is 70 degrees. So this angle here is 70 degrees. So let's move on and look at averages. Mean, median, mode are 3 ways you can work out an average. Range is linked to the topic of averages, but range is not an average, but mean, median, mode are. So what is the mean of the following set of numbers? Now the mean is the only one of the 3 where you actually need to do some maths. So what we need to do is we add them all up and then we divide by how many numbers there are. Now if I add all of these numbers together, I get 671. So the mean is 671 divided by 1, 2, 3, 4, 5, 6, 7, 8. And 671 divided by 8 is 83.875. Now the median is nice and easy. It is just the middle value, but it's only the middle once they're in order. So first of all, let's put the numbers in order. So 2, then 3. Let's cross them off so that we know that we've dealt with them. Then it's 7, then 8. Then it's going to be 12, 16, 17. And then 23, 24. Okay, so let's chop one off the left, chop one off the right. Let's do the same again. And we're going to keep doing this until we expose 1 in the middle, or hopefully it's just 1 in the middle. And as we can see, I've exposed 1 in the middle, so the middle number is 12, so the median is 12. So let's take a look at this data set here. We're going to do exactly the same thing. Let's put them in order. So 12, 13, 16, 16, 18. Then it's going to be 23, 27, 37. So let's do the chopping again. Chop 1 off the left and the right. Let's repeat that process. Let's do it again. Now, unfortunately, we've got 2 in the middle. And the reason why we've got 2 in the middle is because we've got an even number of values. 1, 2, 3, 4, 5, 6, 7, 8. When you've got an odd number of values, you get 1 in the middle. But when you've got an even set of numbers, then an even number of values rather, then you get 2 in the middle. So all we need to do, quite simple, is what is halfway between 16 and 18? Well, that is 17. So here the median is 17. If you get 2 numbers in the middle, let's say 13 and 253, and you need to work out the midpoint of 13 and 253, then just add the 2 numbers together and divide by 2. So if the 2 numbers in the middle were 13 and 253, add them together. 13 plus 253 comes to a total of 266 divided by 2 is 133. So here the median would be 133 if these were the 2 numbers in the middle. Mode is dead easy. The mode is the most frequently occurring. Well, which number do you see the most often? So I can see 46, 1, 2, 3, so 3 times with the 46s. Let's get rid of those. 45, I can see 1, 2, 3 times as well. So let's just get rid of those. 47 appears twice, 48 appears once, and 49 appears once. So in this case, there's actually 2 modes. It is possible to have more than one, to have multiple modes. In this case, the mode is 45 and 46. Although usually in exam questions, you'll just get one mode, but you can get more than one. So moving on to the range is simply the biggest value take away the smallest value. So let's scan through these to find the biggest, which is 178, and the smallest, which is 23. So 178 take away 23 is our calculation to work out the range, and 178 minus 23 is 155. So there is a range of 155. The difference between the smallest and the biggest is 155. Let's have a look at another one here. The smallest is 2. Anything bigger than 23? Yes, 24. So the range is 24 take away 2. So the range is 22. Okay, so here we're comparing 2 data sets. So which class performed better overall? So here I would work out an average. I would go with the mean. So for class 1, I'm going to add up all of these values and then divide by how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we know there's 10 values for each class. So for class 1, 66 plus 84 plus 37 plus 90 plus 82 plus 45 plus 75 plus 77 plus 63 plus 81 comes to a total of 700. Divided by 10 is 70. So I'll just make a note here that the mean is 70. And for class 2, exactly the same. So 80 plus 65 plus 49 plus 50 plus 96 plus 32 plus 83 plus 81 plus 65 plus 69. That comes to a total of 670. Divide that by 10, 67. So I would say class 1 performed better overall, and it's worth stating why, because the mean is higher. Which class was more consistent? Consistency is all about range. So let's have a look at class 1. What is the range? So let's look for the biggest. I've got a 90. Okay, 90 is the biggest value. The smallest, I've got a 37. Okay, so for class 1, the range is 90 take away 37, so 53. And for class 2, what is the biggest value? Have I got a bigger than an 80? Oh yeah, I've got a 96. And the smallest, I've got 49, 32. So here the range is 96 take away 32, which is 64. Okay, so when it comes to range, the narrower or the smaller the range, the more consistent. So let's just write that down. Smaller range equals more consistent, and bigger range, less consistent. Okay, so we want to work out which was more consistent. Well, that's going to be the class with the smaller range, so that is therefore class 1. And again, it's worth stating because the range is smaller than class 2, and it might be worth writing in what the ranges are, just to guarantee that you're scooping up all the appropriate marks. Are you looking for further help to pass your functional skills maths course? If so, then head over to our website passfunctionalskills.co.uk, where you'll find full coverage of all the necessary topics with revision videos divided up into 3 key sections: using numbers, common measures, shape and space, and handling information and data. You'll also find practice tests, exam style questions, and a full set of mock exams as well. So check out passfunctionalskills.co.uk. Okay, let's take a look at estimating the mean. So Steve is raising money for charity. The table below shows information about donations made. Work out an estimate for the mean donation given. Now, if it was an actual rather than an estimate, then what it would be is the total amount of all donations, and that would be divided by the number of donations. Now this isn't going to work in this case, and you'll see why we have to do an estimate. Okay, so first of all, let's take a look at this first row here. We've got 6 donations between £0 and £5. So we'll assume here that this frequency column is people. Quite often the frequency column is people or students. So 6 people have given some amount which is greater than 0 but less than or equal to 5. So, well, what this could mean is that 6 people gave 1p or 6 people gave a fiver. So what can we do here? Because we don't know the exact amount that these 6 people gave, which is why we can't work out an exact total amount. This is why it has to be an estimate. So 6 people gave somewhere between £0 and £5. Well, our best guess is that 6 people donated £2.50 each. So what we're going to do here is we're going to create a column here called midpoint. So what we need to do is work out the midpoint. And this is one big assumption, which is we've assumed that these 6 people, this is our best guess, 6 people donated £2.50. So what's halfway between £5 and £10? That's £7.50. What's halfway between 10 and 15? That's £12.50. What's halfway between 15 and 20? That's £17.50. And halfway between 20 and 25 is £22.50. Now, to work out the mean, we need the total amount of all donations divided by the number of donations. So for an estimated mean, we want the estimated total amount of all donations divided by the number of donations. So if 6 people donated £2.50, then what we can do is work out our estimated total for each row. So 6 people, we are guessing, donated £2.50 each. So in total, that comes to £15. So what we need to do here is multiply the frequency by the midpoint. Now, a lot of people approach these questions, they just write midpoint, frequency times midpoint, and they just know the mechanics of how the question works, but hopefully with this explanation you can understand why we're doing these things. So again, here we know that there are 3 people that made a donation of somewhere between 5 and 10, so we're guessing it's £7.50. So these 3 people donated a total of £22.50, which is 3 times £7.50. 12 times £12.50 is exactly £150. 4 times by £17.50 comes to £70. And £22.50 times by 9 comes to £202.50. So remembering that we want the estimated total amount, so we're going to add all of these totals together, all of these subtotals together, and that comes to £460. So we are guessing by picking a midpoint that we've raised an estimated total of £460. And how many donations were made? Well, 6 were between 0 and 5, 3 were between 5 and 10, etc. So we can see that the addition of these figures here is the number of donations. So 6 plus 3 plus 12 plus 4 plus 9 is 34. So we've estimated that we've got £460 worth of donations from 34 people, or 34 donations in total. Now this figure is exact, it's just the 460 that's a bit dodgy. And what is 460 divided by 34? 460 divided by 34, and that comes to £13. I'll just round it to the nearest pence, 529, so we'll call that £13.53. As I say, some people get these questions right even though they don't know what they're doing. So for an estimated mean, do a midpoint column, frequency times midpoint in another column, and it's this total divided by the total in the frequency column. Much easier to remember if you understand what's going on here, but if you don't understand it, well, if you just follow those steps, then you'll get the answer correct every time. But hopefully, if you just play this video a couple of times, then it's not too difficult to understand. I guess the key thing to remember is often that frequency refers to people, the number of people, and as I said a few times already, we've 6 people have donated between 0 and 5. We don't know what they've donated, so we're guessing that they all donated halfway between 0 and 5, which is £2.50. So let's take a look at probability. We have a probability scale which goes from, in numbers, it goes from 0 up to 1, or sometimes you might see it as a percentage. It could be from 0% up to 100%. 0 means it is completely impossible. So the probability of tomorrow not ending in the letter Y is of course 0 because all the days of the week end in the letter Y. And the probability of 1 means something is 100% guaranteed. So the probability that the sun rises tomorrow is 1 because it's guaranteed to happen. Now, if something is equal chance, so let's say you're tossing a coin in the air and what is the probability of it landing on heads? Well, let's assume it's a fair coin. Well, that is a 50-50. It's equally likely to land on a head or not a head, in other words, a tail. So that has a probability of 1/2. And as a decimal, that is 0.5. In words, you've also got the probability of something being unlikely and also likely. It's hard to put an exact number on what is unlikely and what is likely, but likely has got to be greater than an equal chance but less than certain, so somewhere in this realm here. And unlikely, it has got to be less than equal chance but greater than impossible. So the words can be a bit vague, but if I said to you pick a day at random in March, what is the probability of it raining in Manchester? Well, you might just say it's likely. You're not going to put a number on it unless you've done an experiment and then you've got some data to work with. But if you're just making a general statement, then you might just say, yeah, it's likely. Okay, so let's just take a look at some questions about probability. So what's the probability of throwing a head on a coin? So let's assume, by the way, that we're giving our answers as a decimal. So the answer will be between 0 and 1, where 0 is impossible and 1 is certain. So the probability of throwing a head on a coin, well, that's a 50-50 chance. So that is 1/2 or 0.5. The question might tell you to give your answer as a decimal, or it might ask you to give it as a fraction, so make sure you give the correct format for the answer. What is the probability of throwing a 5 on a dice? Well, you just need to think about a dice and think, how many different outcomes are there? We've got this little equation here. It's fairly intuitive, I like to think. So the probability is the number of ways an event can happen divided by or over the total number of possible outcomes. Well, there's only one way you can throw a 5 on a dice, and that is by throwing the number 5. So it's 1 out of, and there are 6 options. So the probability of throwing a 5 is 1/6. Probability of throwing a 3 on a dice is 1/6. The probability of throwing any number on a dice is 1/6, assuming it's a fair dice. What is the probability of throwing an even number on a dice? Again, it's out of 6. Well, a dice will have the numbers 1, 2, 3, 4, 5, 6. I mean, you probably don't need to write out the numbers to figure out that actually there's 3 out of 6 are even, and we can simplify the fraction to 1/2. Hopefully you could probably go straight to 1/2 because either the number is even or it's odd, and there's the equal number of evens as there are odds. So again, it's 50-50 that is even, 50-50 that is odd, and a 50-50 is 1/2. Or again, 0.5. Going back to the 1/6 one here, I would definitely leave this as a fraction, not a decimal, because 1/6 as a decimal is a little bit nasty. What is the probability of throwing a number greater than 2 on a dice? Okay, be careful with the wording. It's greater than 2, so not 2. So we've got a 1, 2, 3, 4, 5, 6. So greater than 2 means a 3, a 4, a 5, or a 6. So we can see that there are 6 in total. 4 options are greater than 2, so the probability is 4/6. Simplify that down, 2/3. With probability, we need to remember that the probabilities always add up to 1. So when there's only 2 options, if you're told, so for example in question 1, tomorrow we've got 2 things that could happen. It could rain or it could not rain. There's only 2 things that can happen. So if the probability of it raining is 0.9, then the probability of it not raining is 1 minus 0.9, so 0.1. In the second example, the train is either going to be late or on time. So if the probability of it being late is 0.4, then on time is 1, take away 0.4, so 0.6. Again, we've got to work out the missing probability here. So we want to work out the probability of red. So first of all, I would ask, well, what is the probability of not red? So the probability of not red is the probability of blue or yellow or green or purple. So I'd add all of these up. 0.15 plus 0.25 plus 0.3 plus 0.1 is 0.8. So probability of red is 1, take away 0.8, which is 0.2. So just remember, probabilities always add up to 1. Let's take a look at the probability of multiple events occurring. Now we know that the probability of throwing a coin and getting a head is a half. And when you throw the coin a second time, the coin hasn't got a brain. It doesn't think, oh, I've just landed on a head, so I better make it more likely that I land on a tail next time. It's still a half the probability for the subsequent throw. So what do we do with the fractions? The choice that will enter a lot of students' heads is do we add them or do we multiply them? Well, if we were to add them, a half plus a half is 1. Now, a probability of 1 means it's guaranteed. Now, that's obviously, well, that's clearly nonsense, isn't it? Because it's not guaranteed that you're going to throw a head twice in a row, because you could throw a head then a tail, or a tail then a head, or even 2 tails. So we can't be adding the fractions, we are multiplying. So when we are dealing with multiple events, we multiply the probabilities, and a half times a half is a quarter. And that makes sense. If the probability of 1 head is a half, it's got to be less likely that you're going to get a head than a head. It wouldn't make sense for it to be more likely. Okay, what's the probability of throwing a head on an unbiased coin and then selecting a diamond from a pack of cards? Well, throwing a head is 1/2. The probability of selecting a diamond, well, a quarter of the cards in a pack of cards are diamonds, assume when the jokers are not there. So here it's 1/2 multiplied by 1/4, which is 1/8. The probability of a goalkeeper saving a penalty kick is 0.3. What's the probability of him saving 4 in a row? Again, it's not 0.3 plus 0.3 plus 0.3 plus 0.3, because that would end up having a probability of greater than 1. Again, probabilities can't be greater than 1. The probability of him saving 1 kick is quite low, so 2 in a row has got to be even lower, 3 in a row lower still, and 4 in a row even lower. And 0.3 multiplied by itself 4 times is 0.0081, so a very low probability of saving 4 in a row. Okay, so what we have here is a probability table, or a two-way table. So first of all, what you need to do is fill in all the incomplete data. Now, if you've got a column or a row where there's only one gap, you can fill it in. So we've got one gap in this column, we've also got one gap in this row, so we can fill in these parts here. So we know there's 750 people in total, of which 396 are boys, so 750 take away 396 tells us that 354 are girls. Similarly, we know 750 people that is the total, 287 are under 13, so the rest must be 13 or over. So to work out this value here, that is 750 take away 287, which is 463. Now, of the 463, 13 or overs, we know 225 are girls, so the rest must be good boys. So subtract 225 from 463, we get 238. And of the 396 boys, 238 are 13 or over, so the rest are under 13. So 396 minus 238 is 158. And of the 287 under 13s, 158 are boys, so the rest are girls. 287 take away 158 is 129. Now, when I put this final value in, I'm going to add 225 just to check I get 354, and if I do, that makes me confident that I've got everything right. And it does equal 354, so I've got everything correct. Now, of course, you might have filled the values in a slightly different order. It doesn't matter as long as you end up with these numbers, I guess. Right, so what's the probability? A student is selected at random, so we're choosing from all of the students. So out of 750, what's the probability that the student is a girl who is under 13? Well, the number of girls under 13, that is 129. So the probability is 129 over 750. The only question now is, can that be simplified? I don't think it can. Oh, it can actually. I've just typed it into my calculator, and my calculator has told me that is 43 over 250. We can divide top and bottom by 3. Okay, I'm sure in an exam they probably would accept the 129 over 750. Now, this next question here, we need to be careful because we're only selecting from the under 13s. So how many under 13s are there? That is 287. And of the 287, What is the probability that the student is a boy? Well, that is 158. Again, I suspect that this one can't be simplified, although I did say that last time as well, and this fraction cannot be simplified. Okay, this third example, a girl is selected at random, so we're only interested in how many girls there are. So of the girls, so that's of the 354, how many are under 13? Well, that is 129. So again, the probability is 129 over 354, which is probably the final answer. Oh no, that simplifies as well. We can divide top and bottom by 3 again to get 43 over 118. There we go. So do be careful with these questions when you're not choosing from the full student sample. In the second question here, we're just interested in out of the total of the under 13s, and here in the third example, the total is the total number of girls. Okay, so let's look at the final topic, which is scatter graphs. So with scatter graphs, we have a horizontal x-axis and a vertical y-axis, and we have lots of data points plotted. Now, here we've got some data points, and what we can do is we're going to draw a line of best fit. Now, a line of best fit cuts through the center of the dots, trying to keep as many of the data points as close as possible to the line, generally trying to keep the same number above and below the line. So my line of best fit would look something like this. Now, if I ask 2 or 3 students to do a line of best fit, they might come up with slightly different lines, but generally they should produce something like this. Now, if the line goes up, this is a sign that there is positive correlation. And what positive correlation means is as one value increases, the other value increases as well. So what we could have here, for example, is millimeters of rainfall, and up the side we could have sales of umbrellas. And that kind of makes sense, doesn't it? The greater the amount of rainfall, the more likely it is people are going to buy umbrellas. So here we can see that as one value increases, in this case the rainfall, the other value increases, in this case the sales of umbrellas. Now with the second scatter graph, we draw a line of best fit. It will look something like this, and this is a sign that there is negative correlation. And what negative correlation means is that as one value increases, so the x value is increasing, the y value or the vertical value decreases. So this might be number of, let's say, number of builders, and this could be the time taken to complete a particular job. So as we increase the number of builders working on the job, the time will decrease. So 2 types of scatter graph with positive correlation and negative correlation. Of course, you could get a scatter graph where the data is just kind of all over the place and you can't really do a line of best fit, in which case that would be neither positive nor negative. There would just be no correlation whatsoever. Okay, so for this final slide, we're going to plot a scatter graph. So here we've got time in minutes and temperature in degrees Celsius. So the first is a time of 0 corresponds to a temperature of 95 degrees. So time is across the horizontal axis. So let's go to 0 and we want to plot 95. So here is 90, 92, 94, 96, 90. We're going up in 2, so 95 will be here. Okay, this one's done. Now 1 minute 89. So 1 minute is going to be halfway between 0 and 2. So rather annoyingly, it's between these 2 lines here, and we want to plot 89, which annoyingly is going to be halfway between 88 and 90. So it's going to be right in the middle of that square there. Okay, that one's been done. So now 2 minutes 81 degrees. So 2 minutes 80, halfway between 80 and 82. 4, 76, go across to 4, up to 70, 72, 74, 76. 5 minutes, 72, 5 is halfway between 4 and 6, and it's up to 72. So here is 70, there is 72. 8, 55, there's 8, there's 50, there's 60, so 55 will be halfway in between. And 10 minutes, 45, there's 10, there's 40, there's 50, so halfway between 40 and 50 will be there. Okay, so we've plotted all our data points, so we can see that there is negative correlation. I've not drawn in a line of best fit.
So obviously when you're drawing a line of best fit, you should use a pencil and a ruler. I'm just freestyling this with my graphics tablet. This could go horribly wrong. So my line of best fit, which is pretty awful because it's not straight, would look something like this. Okay, so once you've drawn a line of best fit, we can make estimates of other values. So here we want to estimate the temperature of a cup of coffee after 6 minutes. So what we need to do is go across to 6 minutes, and we are going to go up until we hit the graph, which is about here. And if we take a reading across, that corresponds to 68 degrees Celsius. Now, since it's very likely that many students will draw a slightly different line of best fit, in fact, your line of best fit should definitely look different to mine because yours will be a straight line, and I think mine might be a little bit on the high side. You might have got a value of perhaps 66 or 67 degrees C. Generally speaking, it doesn't matter. In the exam, in the mark scheme, they will probably accept a range of values. In this case, they might have accepted anything between, I don't know, 65 and 69. It's just about showing that you can draw, well, you can plot the data points correctly, you can draw a suitable line of best fit, and that you can use the line of best fit to get an estimate. They might always ask you for after how many minutes is the cup of tea 80 degrees. In this case, we're going up to 80 degrees, and we'd be going across to here and just taking a reading down there, which should be, well, somewhere between 3 minutes and 4 minutes. We'd have to work that out. So it's not always taking a reading across the bottom and going across to the other axis. Sometimes it could be you're going up on the y-axis, going across the line, and then dropping down to the x-axis. So don't forget that you can use a line of best fit to predict other values.
Are you looking for further help to pass your functional skills maths course? If so, then head over to our website passfunctionalskills.co.uk, where you'll find full coverage of all the necessary topics with revision videos divided up into 3 key sections: using numbers, common measures, shape and space, and handling information and data. You'll also find practice tests, exam style questions, and a full set of mock exams as well. So check out passfunctionalskills.co.uk.